मूवमेंट पकड़ना किधर क्या हो रहा है। ठीक है, ब्राइटनेस वगैरह
यही है, ऑटो और मैनुअल है।
मैनुअल बढ़ाना है, ब्राइटनेस बढ़ता है।
Now, it's my privilege to introduce Dr. Utpal Garain, sir, professor at Indian Statistical Institute, Kolkata. He is the head of both Computer Vision and Pattern Recognition Unit and ISI Center for AI and Machine Learning of Indian Statistical Institute, Kolkata. Dr. Utpal sir completed his bachelor and master degrees in computer science and engineering from Jadavpur University in 1994 and 1997 and pursued his Ph.D. in computer science from Indian Statistical Institute, Kolkata in 2005. His research interest encompasses AI systems, machine learning, deep learning, and their application in language and vision-based analytics. With more than 150 research publications in peer-reviewed venues and 12 granted patents in data science and AI/ML, Dr. Utpal sir has made significant contribution to this field. His excellence has been recognized through several prestigious honors, including Young Engineer Award by Indian National Academy of Engineering in 2006, the Indo-US Science Technology Forum Research Fellowship in 2011, and the Japanese Society for Promotion of Science Fellowship in 2017. Most recently, he was elected as Fellow of Indian National Academy of Engineering in 2023 and received fellowship from West Bengal Academy of Science and Technology in 2024. We are deeply honored to have Dr. Utpal sir here with us today. Over to you.
प्रेजेंटेशन देंगे ना तो पोडियम और एलईडी दोनों पकड़ना है।
दोनों पकड़ना।
और जो ऑनलाइन होगा ना,
हाँ,
उसमें सिर्फ एलईडी पकड़ना है। ठीक है।
Okay, very good morning. Today I'll speak on this, being an AI researcher. Now we are basically in the area of Gen AI, generative AI. Now, should I wait for 5 minutes? Other participants are coming. Or should I continue? Switch for 5 minutes?
अपने हिसाब से बैलेंस कर लेना। ठीक है।
Okay, let's proceed. So, what is the, goal of this talk? So, I see that mostly students from computer science, right, in electronics. Right. So, you understand the situation today, right? That so in this is a very disruptive situation because of AI, and so there is a fear of losing jobs, difficulty in getting jobs, right? So all these things are we are basically these difficulties we are facing nowadays, right? But there is one good thing I can tell you, that everybody is talking about AI, machine learning, deep learning, etc. School children are talking more than you or more than what we do. It's not really exciting. Yeah, very good. But last week I was attending a conference, and here one professor, you know his name, Professor Roy from IIM Ahmedabad. He gave a very interesting statistics, and he was quoting from MIT review that in spite of all this, AI integration in industry is not even 5%. So as of now, when we are thinking that AI is taking everything, right? But AI integration in industry is not even 5%, right? But we are using AI at the personal level like anything, right? Even school children are losing interest for learning because of AI. They see that everything is available, LLM, ChatGPT, GPT. So now, so we we are basically living in that era. So goal is to understand that, okay, what is the power of AI, specifically Gen AI, and then, so most of you from computer science and electronics, maybe some other engineering branches, and then I assume that most of you will go to industry, right? And then some of you will go for higher studies. So in both cases, I mean, so power of this Gen AI is very, very important. But today I'll talk more about manufacturing. I mean, in industry, industry 4.0 and subsequently 5.0. Because I mean, this is being an institute of technology in manufacturing. But if you have interest to know about the research directions in today's AI, definitely you can ask me questions. Many technical things probably I will skip, but if you have any question, you can ask me from language, from vision, any issues related to LLMs or even vision language models, VLMs. Okay, so feel free to ask me questions outside my talk content. Now, so whenever and being an engineering student, so we dream to get great jobs in industry, right? And then industry is involved in manufacturing, whatever it could be big scale industry, completely in production. It could be for IT sector, whatever. So being an AI engineer or AI researchers, even after finishing your higher studies, so many of our scholars, they have interest to join industry to work as AI researchers, right? But for the industry. So we should be, if you want to do for engineering, certain things we have to keep in mind, right? So that is the goal of my talk, that you can do computer science, you can specialize in AI, machine learning, but learning just coding, some machine learning theory will not help you to get success in engineering or in manufacturing. So what are the issues related to this? Now, before we go more into manufacturing, let's see that what is the power of this generative AI today, so that this disruptive situation has come, right? And I told you, personal level, we are using AI like anything. It's almost, we are thinking that AI is going to take over our job, our life practices are getting changed. At the same time, what are the problems of AI, so that industry integration of AI is not even 5%, right, as per MIT review. So first, let's see what is the power of, probably I'll speak for 45-50 minutes, okay, and then you can ask some questions, or in between also, I mean, you can stop me and ask questions if it is relevant. Let's see what are the capabilities of today's Gen AI. First one, no doubt that content creation and augmentation, right? So I'm sure that nobody is writing any article for assignment. You are not doing it, just giving the assignment problems to the GPT. GPT is writing assignment for you. Even it's meaningless to write for emails also. Probably you are using GPT to write emails or whatever, everything, right? Everything. So this content creation is great, even coding also, right? So coding also. And as a professor, so many professors, they complain. In fact, last week I attended an AICTE program, and their professors were complaining that students are not getting enough coding skill, right? I mean, so for example, being a computer science student, say 30 years before, if you compare my coding skill with your coding skill, then there is a difference, because coding was the main thing that time, right? If I could not code well, job opportunity for me was less. At the same time, for you, if you do not know how to use GPT to code something, right, you will be in problem. Why? Because industry's demand is, given a problem, you will do it yesterday. Now, if this is the demand, that given a problem, you will implement it, you will produce the results yesterday, it is not possible that you will code from the scratch, right, for a big problem. You have to use available Gen AI capability to code, right? And then, so now obvious question is that if LLM can code for me, what is the use of me as a computer scientist or as an electronics engineer, right? So there the very vital question you ask yourself, that what skill do I have to be relevant in this age of AI, right? Do I have a skill that so that I'm not easily replaceable, right? So now, if you seriously use GPT for coding, it has not achieved the industry level efficiency, right? Say probably 80% is right, sometimes 90% is right, even 95% is right, but the 5% mistake could be damaging. Now, as a computer scientist or whatever, I mean this, if you have that ability to go through the code and fix those points, maybe one line mistake is there, and that could be because you know that hallucination and then many other problems are there for LLMs and VLMs. If you can fix that line, you are not replaceable in the industry, right? Because you have that ability, right? But if you think that, okay, upload my assignment and then whatever you get from GPT, submit it, mind it, you are easily replaceable, right? Nobody will recruit you to do this job, right? Non-tech job, right? So that is the augmentation part. So even let's say you write an email and then you give it to ChatGPT that can you rephrase or correct my English, and so augmentation. That's why you are not getting the content from email. So whenever we write research papers, GPTs are very poor in writing good research papers. So that's why we write. We use GPT for English correction, sometimes for research ideas, right? But not to get new research ideas. It's very, very tough till now. But very soon it will have, I'm sure, the way the things are progressing. But to augment, that augmentation is important, right? And then this automation and efficiency, it has surpassed human ability, no doubt about it, right? Even let's say if you work with doctors, so doctors can read 2 books, 4 books, 10 books, and GPT has read thousands of books, right? So that automation efficiency, that is the another power of Gen AI. And deep understanding and personalization, right? Personalization, everybody of you, you have experienced. I mean, the kind of medicines you are taking, I do not know, right? Even but GPT knows. I mean, AI knows. That kind of books or clothes or whatever you are doing, that so GPT, I mean, the AI knows your interest, your purchase profile, everything, right? And that personalization is very effective for giving advertisement to you, right? So you don't read books, so it is meaningless to give you advertisement for books, right? So maybe you are looking for, you are interested in a particular brand, or maybe you are looking for cars also, right? Or let's say bikes. Then that personalization AI knows, and then that's why marketing strategies is becoming very efficient today because of this personalization, right? And data analysis and insights. So most of the, I mean, that's why a new branch has come, that data science, data analytics, right? And then new possibilities are there, new possibilities in the sense using the power of AI, that we can go for digital twins for physical systems for simulation. It is very effective for medicine, for retail business, everywhere. That can you have a digital simulation, and then you can understand the kind of business you want to do, right? Now, if these are the main powers of AI, then how these capabilities you can use in manufacturing, right? Now, in manufacturing, whatever I mean, but the problem we can go for some case studies in manufacturing. But whatever you do, you see one big problem is decision making, right? So some of you probably were interested to initiate a startup, right? Now, if you have a startup, I mean, interest to, then so how can you do decision making? Say optimization of the manufacturing process, right? That you want to manufacture something. Now, what is meant by optimization in a manufacturing plant? Optimization actually indicates many things. We'll talk about those things. And then we deal with robots in factories, in manufacturing anything. So could be a small scale robot, but basically it's a automation, right? Even in a biscuit company like Britannia, they also use robots, right? So that now robots are becoming intelligent because of Gen AI. So two robots can interact through prompting, right? And you can interact with a robot, and those systems are called vision language models, that VLMs, that you give prompt to robot, and robot is taking help of camera, so computer vision comes, and accordingly the robot is taking an action, right? So human robot interaction has become very efficient, and robot interaction is also gaining a very different state of the art. And then a lot of innovations. You can use Gen AI tools, mostly LLMs, and give data. Let's say you are doing a business, you give that the entire business history or whatever you have to the LLM, and you can interact with the LLM to understand that what kind of innovation you can bring to your business. Okay, and again you see that. So today the question is, whatever we do, I mean, you can study history or computer science or statistics. If you do not work with AI, that you will be old-fashioned, right? It's not that AI will replace me. The question is how to work with AI. That skill we have to learn, okay? And then you can get new ideas about the product or marketing strategies. And inventory management, yes, that part is almost, I mean, Gen AI is managing inventory in a way, again, it is surpassing human capability, right? Now, so we have talked about Gen AI capabilities. We have seen that how these capabilities are being used in manufacturing, but again, it's very less. I mean, that's why, I mean, this question will come to you that, okay, if Gen AI is so much capable, then what is the reason that less than 5% integration is there in the industry, right? Now, so because you were students, I thought that we should talk about some foundation, right? Some foundational aspects. So finally, I'll talk about a roadmap if you want to pursue that in manufacturing as an AI engineer, what you can do. But one thing that learn basics of statistics and probability well, right? Otherwise, you won't just be a data engineer getting a BTech or probably MTech. Finally, some of you will have Ph.D. So this understanding of statistics and probability is very important. Along with certain things, we'll talk about all this. But you see that whatever we do, even not only in manufacturing, in some other fields also, in your daily life also, either the task is a classification task, right? Or what is meant by classification? So classification is, these are the typical examples, that object detection, you see someone, oh, I know the face, right? So this is a recognition task. And then sentiment analysis, say you read something and then you want to classify that this is a positive review or negative review. Let's say you have a business, a restaurant business, and then customers are giving you reviews, right? So how to classify that review is basically a positive review or negative review. So again, you see this is a classification task, right? Even you are judging a friend, that is my friend good or bad? It's basically a classification task, right? So most of the tasks so far, this generative AI has gained its popularity due to classification task. Okay, but where is the difference? For if you want to implement a classification task, this is called supervised machine learning. What is supervised machine learning? Let's say you have a label, you have a sample, but label is also, somebody has given you label, right? So for example, I want to do face recognition here. I need face images of everyone, and who is that person? That label. If you do not give me that label, then classification task is not possible, right? So for example, you want to do sentiment analysis. So I need samples, data, that okay, for this kind of review, you call them positive review, this kind of review negative review. That labeling is needed, and that's why it is called supervised machine learning. And so far, I mean, the success we have in our AI industry based on supervised machine learning only, right? Mostly, I mean, but unsupervised machine learning is still very tough, and not for data visualization and other things I'll show you. And that's why, I mean, last year I was talking with Amazon India machine learning group. You will be surprised to know that they recruit 1,500 annotators every day in their Hyderabad office. They come, they annotate things every day, and so this much, I mean, labeling effort is needed. They spend so much money, and that's why all these AI magics are possible. It's not that you have some AI, you apply AI and you get the magics, right? So supervised machine learning is so far, it's mostly the success we have got. And then for unsupervised machine learning is clustering. So in daily life also, we have practice clustering. So for example, you have so many students here, right? So you start with a big cluster, and then more you mingle with the people, you will find you are forming small groups, right? Based on something, you do not know based on what, right? But certain features, certain characteristics, you find more attracted to that particular subgroup, and probably you will form 10 subgroups from this entire population, right? So this is classification. Now, sorry, this is clustering, right? And you see that nobody is telling you that, so these are the features, this is the level of this person, this is the level of another person, and these two levels, if they match, they will form a cluster, right? Nobody is telling you that what is the level, right? But you see that through some interactions, you are forming small groups, you are forming clusters, and nobody is guiding you that you should. So it's not that, okay, first year students form a cluster and then second year students form a cluster. It may not happen, right? So label is not there, but still sometimes this is very useful for data visualization. For example, I give you a data set, right? And then, okay, so I give a real life example. Let's say you have a retail business, a lot of customers are coming, right? So, and using your retail business, how can you segment the customers? Nobody is giving you that this customer is good, this customer is bad, this customer is, I mean, dormant for last 6 months. Nobody is giving, because that is very expensive, right? So I give you data for, let's say, 10,000 customers, right? So then what I can give you, okay? I have customer address, customer purchase history, everything. Now I tell you that can you segment the customers into 5 different groups, right? So you need very effective clustering algorithms, okay? And you see this is unsupervised. And another task is called regression. And okay, regression, most of you have practiced regression, but that is needed for prediction. So for example, some of you, if you are investing money in stock market, can you predict that what will be a good stock and which is not a good stock, right? So in manufacturing, can you predict that this transformer will be probably out of order in next 15 days? This is a prediction task, right? Can you predict that there will be an outbreak of a disease maybe in 1 month, right? So this task, you see, these are different from classification. The task is not that who is this person, right? Task is also not clustering, right? That group them, form subgroups. The task is to predict something. Then, so this is another task. So mostly if you look at that use of AI, generative AI in different problems in manufacturing or whatever, right? Basically, we are dealing with one of these 3 problems or combination of them, either clustering or classification or regression. So these 3 things you study well, right? To get the idea that how things are moving. So whenever you get a new system, new models, you try to understand that what type of classification strategy is changed so that this model is performing better than the older models, right? Now, okay, so this is unsupervised. Let's say you start with this data set, and finally, if you have an algorithm to group them into 3 different groups, then your clustering is, probably you have a good algorithm in hand to do clustering, right? Now, so in image processing, we do clustering. Say, for example, if you are given this image and I ask you that can you segment foreground and background, right? So basically, all the pixels, you are grouping them into one of these 2 classes, either foreground or background, right? So this is clustering, but here you see this is a hierarchical clustering. You start with a set of cars, and then you finally see that these cars are basically sedan type, these cars are hatchback type, and then within the sedan group you can have different models, within the hatchback group you can have different models, right? So this is called hierarchical clustering, right? But you see that nowhere I am giving you the label that this is sedan, this is hatchback. Nobody is telling you, right? So based on some features, you should have a suitable clustering algorithm so that whatever you want, that insight should come out, right? Now, typical, many of you probably know that K-means is a very useful clustering algorithms. If you do not know for K-means, take a note of it. You should know K-means, okay? And then there are hierarchical clustering and DB-scan also, that is density-based algorithm. Then let's see if I know clustering, right? And then during interview, if somebody asks you that, okay, you know clustering, main problem in our teaching is that we know many things, but when this, people in practice, they ask us that where can you apply this knowledge, then we do not know, because there is a big disconnect, right? Now you see that if you know clustering, how you can use your knowledge in industry so well, because there are so many problems in industry which are basically clustering. So one is that defect analysis, clustered defect data to pinpoint common causes and prioritize solutions. So for example, let's say you are manufacturing electronic voting machine, right? And then you find that 5% voting machines are defective, right? Then their problem is that can you pinpoint the reasons? What are the design faults, right? And design faults may not be a single one. So you start with this 5% data, and can you cluster them and try to, let's say there are 3 clusters, and for each cluster, can you identify that these machines are faulty machines because of this problem? So second cluster, these machines are faulty machines because of another problem. Then you identify 3 different problems for 3 different clusters, right? And then for supply chain management also, segment suppliers by performance, reliability, or cost efficiency. Similarly, you can segment the customers also. Nobody is telling you that these are the parameters you should use. You use whatever is available with you. Then the moment you get clusters, right? So for example, you can do a very nice exercise. You take different news articles from newspaper and cluster them, right? And then if you find, oh, these, say in the first cluster, I got the documents, articles, which are political news. In another cluster, I got the articles which are sports news. In another cluster, I got the articles which are basically entertainment news, maybe say cine news, or I mean mostly page 3 things, right? Then you can be very sure that I have some clustering algorithm that can cluster things so nicely, right? But nobody is telling you that political news are tagged, right? Nobody is giving you the tag that this article is political, this article is sports, this article is entertainment. Nobody is telling you, right? But if you can achieve that, that's a very, similarly for customers also, right? And then, when we talk about classification, so it's a very nice linear classification, and then problem is that not everything is linear, right? So for example, this is also a classification, but you see that classification boundary is not linear, right? If everything is linear, we could have managed it by straight line, right? So very simple straight line, y is equal to mx plus c would have helped us, right? So the main problems in classification is that most, I mean, in reality, the patterns are not linearly separable. That is one problem, right? And then, so it is not very easy that I can plot them on 2D, right? Each data point has x-axis and y-axis. The main problem is that multi-dimensional data, that most of the data has so many dimensions, right? And then problem is you cannot plot them to see that whether they are linearly separable or not. Say I give you 4-dimensional data, right? Say there are x1, x2, x3, x4. How can you visualize that whether they are linearly separable or not? Very tough, right? And number of classes also, it's a big problem. That I mean, here we are dealing with 2 classes, but there are problems where number of classes is very high. Say for example, you want to do character recognition, right? For English, how many classes? Maybe 100, lowercase, uppercase, and this. And for Indian languages, you know the problem. In Hindi, how many characters are there? In Indian languages, number of classes is so high because we developed Devanagari OCR. We know that, I mean, so there are basic characters, conjuncts, and then consonants, and then so many. So there are more than 400 classes. So number of classes will give you the complexity of the problem for classification, right? Now let's see what are the classification problems, common problems in any manufacturing plant. Say defect detection. Earlier we talked about that I give you the defective machines, you cluster them, try to find out the reason. But defect detection itself a classification. Say you produce a pipe, right? Then can you design a computer vision system to detect if there is any fault or not, right? So that defect detection is a very, very well-known problem, well-studied problem in industry. Mostly vision or mathematical models are used for defect detection. And then another is that predictive maintenance. So for example, for expensive equipments, if you constantly monitor them, that whether the equipment is normal or it's a warning stage, right? Or it's a critical stage, then probably you can save a huge lot of money for the company. That okay, because you know that so if you you have a very close connection with Tata Steel. I'm sure that one speaker will be from Tata Steel. If you talk with them, you will understand that if a boiler is suddenly shut down for few hours, they lose huge amount of money, right? But if you can predict that this boiler can be defunct in 7 days, you can save huge lot of money, right? So that's the predictive analysis thing. And even with Timex, we had a project once. Timex, I mean the watch company, they had the similar kind of problem that can we monitor the machine health? So that's why a new branch has come called machine prognostic, right? Machine health. And similarly, demand forecasting is very, very important problem everywhere, right? Even if you print newspaper, if you say medicine manufacturing, can you forecast the demand, right? So that is the predictive problem. You see that if you can predict that the demand is very high, medium, or low. So here the predictive problem, we are configuring it as a classification problem, right? So that's why we were dealing with these 3 classes, 4 classes like that. And then again, so a lot of workforce management that so you want to characterize your manpower, associates, that they are very efficient, not very efficient, or underperforming, right? So again, you see, based on certain things, what the people in industry that do is basically classification. Even the recruiters today, whenever you submit your biodata, nobody is, I mean, going through your biodata, no human expert. So there are AI agents, and immediately they rate your biodata. So that's why, I mean, sometimes you can play with jailbreaking methods. You know jailbreaking? That okay, you put your biodata and you are rated at okay, not that great biodata. Can you change certain keywords and then fool the AI system, and your biodata will be rated as that very efficient biodata? Probably you pass the first screening, and those are completely AI agent based, right? But you see, again, it's a classification problem, right? That can I rate a biodata as good, moderate, or bad, right? So these are, I mean, major classification techniques and neural networks. Earlier, support vector machine was very popular, and decision trees are very efficient, easy to implement, and random forest came, which is probabilistic. But today, because of that mammoth performance of neural networks, we are dealing with neural networks only, right? Hardly people we talk about support vector machines today. Decision trees, sometimes they are useful when the problem in nature is not that complex, but anyway, not that efficient like neural network. So those who, I mean, neural network, you understand, I need few hours to explain you all the aspects of neural network. But just as a brief, neural network, in fact, you know this, all these AI neural network are quite old. AI started in 1950s, right? So Alan Turing, 1950 exactly, he gave that imitation test theory. What is imitation test? That's why you know is Turing test. Say one task is being done, right? Now you are asked that what do you think, the task is is done by a human or task is done by a machine, right? Now if you are not able to tell that precisely whether the task is done by a human or a machine, then that task is passed the Turing test, right? So it is fooling you that you do not know, and that is happening today, right? If I write an article and then I mean, teachers are fooled today that whether assignment is done by the student herself or it's taken by GPT, right? So professors are fooled, school teachers are fooled. So that's why many systems are passing the Turing test today, and it was proposed in 1950. So after these 75 years, you see, we have achieved that state. And sometimes we now, for many cases, we are surpassing the human ability. And 1955, that AI, artificial intelligence that came, and then neural networks also introduced quite early. So what was the problem? I mean, if you read historical articles and novels, the same kind of situation was there. Doctors were discussing that these expert systems, are they going to replace doctors, right? And then a lot of hype was created, right? And then around 70s, people started to understand that it's not possible. I mean, it was a hype, and that's why that is known as AI winter, right? Now, again, because of certain things, AI has got a rebirth because of big data, new algorithms like convolutional neural network, recurrent neural network, and then transformer, and all these today's Gen AI models, what you see, are based on transformer, which came in 2017. And right, and the deep learning idea, right? So do you have idea about, I mean, the main features of deep learning? If you want to compare it with traditional machine learning, or should I tell you? What is deep learning? Okay, so deep learning is again a newer term, not very old like artificial intelligence or neural network. So machine learning we have been practicing for a long time, right, in statistics community and computer science community. But if you look at any machine learning system, there are main problem is that who will give you features. Say for example, you want to do face recognition, right? Even very simple things. Say for example, you want to do alphabet recognition. How to recognize which shape is A, which shape is B, right? Which shape is C, which shape is D, right? So we, the way we teach a child, we follow the same thing for machine learning algorithms also. That so describe A as say there are two straight lines, and then I mean tilted straight lines joined at the head. They are joined at the middle by another straight line, right? Right, and the way we teach our children also, that this is B on vertical line, there are cup shape things. This is traditional machine learning, that features are coming from human experts. So for example, if I give you ECG, right, and ECG signals, and if I ask you that, can you design a system that will take an ECG and tell me that whether any cardiac problem is there or not, right? First thing, you have to talk with a cardiologist, that how to read ECG, right? And how do you identify that this is a cardiac problem, or there is no cardiac problem in the signal, right? So, so that was traditional machine learning. Even face recognition, right? You will talk with the forensic experts that how do you recognize face images, right? Thumb impression, how do you recognize thumb impression? They will give you very nice ideas that the way they do it. Now, so this was going on for many decades, and then the community questioned two things. One thing is that, is there any way to get rid of this dependency on the domain experts, right? And second thing is that whenever you are talking with the domain experts, what is the guarantee that the information, the knowledge I'm getting from the domain expert is perfect? Because as a computer scientist, you will depend on the domain experts. Domain experts will tell you, we do it in this way, and we'll try to emulate that, right? So what is the guarantee that so domain experts is giving us the, and that happens with doctors also, right? It's not possible for every doctors to know everything, right? And so there are gradations also. So that's why the idea of deep learning came. Deep learning wanted to get rid of this situation, that what happens if I give data and to machine and let machine find out the right features to accomplish a particular task. So I can give you a very similar analogy. Let's say you are teaching a child ABCD. One way is that you describe what is A, what is B, what is C, right? You need less amount of data to teach a child these alphabets, right? But if you do like this, that okay, I'll not tell you that how to write A, how to write B, but I'll show you A images, B images, C images, and I'll tell the child that this is A, this is B, this is C. If you do it for many times, then you will see that child has learned what is A, what is B, what is C, but how you do not know. So brain is extracting features, may not be the straight lines or hub cup shaped, etc. So, but brain is extracting right features to say A as A, B as B. So this is deep learning, right? And so deep learning came around 2006 by a famous paper from Hinton. That changed the situation. So that's why today, if you do face recognition, so you need huge data, right? Because you are not telling the features, right features. So you are giving lot of face images for the same person, and you are telling the system that this is person A, right? But not telling that how to recognize person A, right? Now, this neural network is achieving this, but see, the original story was as if this neural architecture is mimicking the human brain. But I mean, don't believe in those stories, because we are far from the biology. But at the same time, okay, goal can be with this, so in return, what we got is a marvelous engineering success, right? So we cannot ignore that success also in field of engineering. But I mean, if you talk with brain surgeon or people, I mean, what is so it's not that brain neurons. So Hinton assumed that probably neurons are arranged in different layers, and that's why he introduced that it should be not one or two hidden layer. You increase the number of layers, and that's why now deep systems came, right? So for example, ResNet 50, ResNet 101, ResNet 151, like that, right? But I mean, in biology, we do not have concrete evidence that how neurons are arranged, or how does exactly brain work. It's very difficult, but a lot of research has started. The problem was with MLP and the idea of deep learning. Already I told you. So this is, we can say that, okay, this we can consider as one of the very big success for using deep learning. This is the ImageNet challenge. So earlier problem was we were dealing with 10 plus problems. So for example, MNIST, probably all of you know about MNIST. So what is the goal of MNIST? That recognize the digits, right? 0, 1, 2 handwritten digits. So you were dealing with 10 pluses. But if you want to achieve human level vision can recognize thousands of objects, right? So it's not just 10 or even 100, not even 1,000, probably few thousands. So that task was designed to understand that does a machine have the power of that, can achieve power of human vision, right? So this task created 22,000 different categories, right, of different objects. But at the same time, you see the amount of data needed. So 14 million images, and all, because this is a classification task, so you need labels, right? 14 million, and then 2012 AlexNet achieves that error is only 16%, and today error is less than 5% for ImageNet. So that shows that machine has gained that ability to recognize this many different objects. But what is the requirement? Requirement is that enormous, that's why the term big data came, right? The big data. Now question is that many people, they argue that human vision, do we need this much data to learn, right? Now obviously question is no, because say I do not show you 500 images of chair to teach you that this is chair. Probably 1 or 2 samples are good enough, right, to tell you, to teach you that this is chair. But interesting evidence that comes from psychology, I mean this clinical psychology. A child learns its mother not by seeing once or twice. Maybe thousands times, right? Few thousand times a child sees its mother, and then only the child can recognize that she is my mother. And not only the vision, say the way the person walk, gesture, and then audio, the way mother speaks. So this is a completely multimodal system, and not only 1 or 2 or 10 or 100 samples achieves that, right? So but now question is that, okay, that happens for mother, maybe when human brain starts learning things. But then that is also happening in our AI also. Then probably you can bring a very different chair today, and one sample good enough to learn that, okay, this is a chair. Next time you just show me that kind of sample, I'll tell this is chair. That is happening because of pre-training, transfer learning, right? So probably, and that is happening with LLM also, right? So exact the work you want LLM to do, probably LLM is not trained on that, but still LLM can do, and that's why say you can go for in context learning, right? So for example, you tell LLM that I want to do it, give some example. Okay, so for example, LLMs are very poor in counting. Probably you have noted it. You tell them LLMs that write this article in 100 words. They are very poor in counting. Now you tell them that this is Utpal, this is 5. There are 5 characters, right? And this word has this many characters. You give some examples, right? And then because of that in context learning, LLMs will understand what you want to do, right? And still they make mistakes, but you see that that kind of power today these Gen AI systems are gaining, that because of huge speed training, right? LLM is most of the LLMs today, especially GPT, it has seen 15 trillion tokens. And what is 15 trillion tokens? Probably in our older 5, 6 or 10 generations, they altogether they could not read these 15 trillion tokens, but GPT has read that 15 trillion tokens, right? So this is the huge pre-training that is making possible. So probably this human ability that after just, and that is in context learning, right? Just you give me samples of 2 new chairs, and 4th chair, you whenever you show it to me, I'll tell this is chair, right? So that is happening because of pre-training. Now for language processing, okay. So probably I'll take 5 more minutes, then we'll discuss. Thing is that you will be interested to know that, okay, fine. So these are another success stories. I mean, the way you see that history, that so earlier one is just image, right? That you show image, it will tell the class. Now so 2015 we got systems that can interact with language and vision both. So task was, you will show an image to the computer, and computer will give a caption for the image. So this is, you look at this, a person riding a motorcycle on a dirt road, that is the caption given by the system, given by the model. So human ability is not the vision ability, right? We have language ability, we can write, then speech ability, audio ability. So all these abilities are coming together, and systems are becoming more and more multimodal. So here also this is another task, still it is ongoing, VQA. Some of you can try medical VQA, it's very interesting. I mean, what is the task? You show an image to the computer, you ask a question, right? So this is VQA, visual question answering, and machine will give you the answer, right? So this VQA is still active, but I think more interesting will be if you do VQA for medical. I mean, so the data set is there, you can try some kind of assignment. Okay, here a small thing. So for example, for this image, who is wearing glasses? Here it is man, here it is woman. this so that the data bias is not there. Let's say for if you have only images where man is wearing the glasses, right, then system will learn that bias. And then whenever you test, probably if the woman is wearing the glass, machine didn't learn, right, that who is wearing the glass. So to mitigate the data bias, so this kind of data set generated, and now this is the LLM history. Today we are here. We do not know what is the model size, how many. So more or less it is 573 billion parameters of a GPT-5 has come. Now, yeah, so obvious question, how to prepare in this situation where this enormous power this Gen AI has got. So this is my prescription that if you want to work in industry, domain and data is very important. So this deep learning community, we started with this assumption or with this goal that probably the domain experts, we can get rid of them, right? Now after say almost, I mean, working for 1 decade, let's say around 2020 or before that, the community started learning this, that role of domain experts is very, very important, right? So if you do not know a particular domain well, earlier we used to claim that, okay, give me data, I can achieve anything. What do you want? Just give me data. It's not possible, right? So try to understand the domain and the data, very, very important. The data you get, right? And then this is the manufacturing workflow. So whenever you are going for any internship, probably you are given a small problem in the industry. Try to understand the process, right? Don't think that, okay, I'll write the program and that will do some magic. It's not possible. If you do not understand the domain, if you do not understand the data, right? So for example, and there is a problem, say, if you work with a biologist, right? In biology, there are huge amount of data, right? But you see, we are not able to apply machine learning properly for biology. The reason is that we do not understand the domain, we do not understand the data, right? We know some tools, right, and Gen AI tools. But how can you use those tools to solve a biology problem, right? This is happening in many areas. So basically, to learn data basics, so for example, if sensors are there, what kind of data you are getting from the sensors, then data, different databases, so for example, how data is stored in different databases. You must have these skills. So for example, why Python? Because most machine learning happens in Python, right? So so learning Python is very, very important. And then and there is a problem again that will create a lot of debate. Say for many non-com C people, we are teaching C, and many professors, they claim that, oh, no, you should learn C because C is the mother of all language and etc. Oftentimes the main problem is that I know C, that's why I want to teach you C, right? And that is my alibi that, okay, why do you know C? And finally, you can understand that C has no role in that, so if you are not studying computer science. So for example, in many colleges, even economic students are also taught C because professor doesn't know other languages. That's the problem, right? So, but for my prescription is this: learn Python well, okay? And because most of the machine learning happens in Python, so you will work with data, right? Whatever data it is, right? And then, what are the libraries? These two libraries, other libraries are also very important. Pandas and NumPy for data manipulation. These two libraries you learn, and I think that will cover most of the things. For machine learning, scikit is very, very important because it implements all the classical machine learning things, SVM, neural network, random forest, whatever. So you can just play with data. And some basic deep learning things, say for example, okay, TensorFlow is little bit less used today, but we use PyTorch. So move to PyTorch platform, and many other newer platforms are coming. Fine. So, and then these are the use cases, right? So you know so many things, but where will you use this knowledge, right? So can you pick up a predictive maintenance problem, or let's say quality inspection, that defect detection and etc., and process optimization, say, then can you cut down speed, so to tune parameters like say feed rate or furnace temperature, so these are the, so whenever you are trying to optimize something, what do you want to optimize, right? These are the things. Sorry. Okay. Now this data is very important. That's why we should know that how to collect data, because in India main problem is that even for big companies, I have very strange experiences that very big company, multinational Indian company, they invited us, and then the problem we understood, they have used data, but they do not know what to do with that data, right? But question is that, okay, so that is also difficult for us, for you also, that okay, for a company, what you can do, so that, so final goal is to improve the revenue, right? Even if you for very big companies, if you can improve, enhance revenue by 1% or less than 1%, they want to spend for AI/ML, right? That 1% revenue increase for certain companies is great. Okay. So right. So for as most of you are students, so my suggestion, you do small pilot projects, right? Say for example, these are the very nice examples that detect tool wear from sound or vibration. So you will learn to deal with different kind of data. So sound data, even use your mobile. Mobile is a very nice accelerometer, right? Gyroscope. So try to use those kind of sensors and see that, think of a small problem and see that what you can achieve. And for if you want to make yourself ready for industry AI platforms, these are very nice tools. Say for example, this is for Siemens. Most of the IoT platforms, AWS IoT, Azure IoT, and then Schneider has another platform. So to conclude that, power of Gen AI has to be exploited, right? With a caution that again, for AI community, we can have another winter, okay? But you do not know, right, whether AI winter will come or not. But we have to make ourselves ready for to work with AI, right? And then to work with AI, human in the loop is very important. You can fool professors like me. You upload the assignment statement to GPT, get it, submit it to me, and I'll see, oh, that's a very nice student. So you are not fooling your professors, you are fooling yourself also, right? So so human in the loop, in the sense, there are professors like this time, the semester just ended, I did something that is called Poisson prompting, right? What is Poisson prompting? That something you add which is not visible to human, right? So for example, color is white, or font size is such that. So I made it color is white. So 3 students, they uploaded the entire thing to GPT, but it is not invisible to GPT. So I wrote there that while writing this code, give a variable name LLM with 3 L's, LLLM, right? And another variable as counter with a wrong spelling. So these 3 students submitted it. They didn't go through what they wrote finally. They submitted it, and because of that Poisson prompting, I called them. That probably you have done a great assignment. So how much time you spent? So they cooked up stories. I wanted to listen to them. That okay, let them go ahead. Be careful about that thing. Okay. So so that is the human in the loop, right? Because in industry, I told you, they will give you a task. They want that you will do it yesterday. If this is the demand, you have to use Gen AI tools, right? But human in the loop is you, right? That what is given to you, you have nicely executed it, right? And then, so for understanding of data process, core technology is very important. Today, I didn't get enough scope to tell you what are the technology milestones you should be very, I mean, carefully you should learn, right? So, see, for every one of us, it's not possible to know everything, right? But you should have some idea about the things, that how LLM works, right? You should have some idea. So that is very important for you. So if you want to contribute in manufacturing, in challenging this, any challenging things, and today whatever is challenging, without use of Gen AI, it's not challenging it, at least. Okay, with this, thank you very much. If you have some questions, probably we can take 5 more minutes, right? Yeah. Any questions? I mean, not, yeah, please. No, this is worldwide statistics, not in India. Yeah. Right. Yeah. No, say, if you use Gen AI, what are the benefits you will get? Efficiency will increase, right? Efficiency will increase. Finally, say any industry, say in India, problem is that first thing, India, most of the companies are not ready to work with AI, right? Because they have IT departments, but that IT department, most of the manpower are old fashioned, right? So this disruption has come, let's say November 2023, right? This LLM came, right? Before that, this enormous power of Gen AI was not that useful, right? So how can you expect that this IT team is, so that's why they are involving startups. Because startups are sometimes, because young people like you, maybe 2 of you, 4 of you, you are working in a startup and you know technologies better than IT team of a very big company. Probably they are getting lakhs of rupees as salary, but I mean, knowledge wise, they are much below you, right? So it will take time. Question is that they will spend money only when they will realize, and look at the management level people also. Unless and until you can give them a very clear picture that if you use AI ML, this is the possible revenue enhancement. Because they are not, I mean, even not only India, nowhere, right? Somebody is very expert in say steel plant, right? Now you have to convince that if you use this, then how you can improve your revenue for steel plant also, right? So that's why, I mean, it is 2%, probably less than 2% in India, but it will catch up. Certain things where we do not have any, so manpower orientation will be there. Certain jobs won't be there, and new jobs will come. So, for example, certain monotonous job, right? So, for example, security guard, right? If it is not very critical, you can manage with computer vision system, right? So instead of 25 security guards around the campus, just 2 people can sit with big monitors and they can manage, right? So certain jobs where we do not have any problem, but for doctor, you cannot replace them, right? So that these are pilots. So even in India, autonomous car is not possible because these are mission critical applications, right? So mission critical applications, human must be in the loop. For certain jobs, AI will replace, because these completely, even in many IT companies, right? So for example, you look at the log and identify the problems, AI can do it, right? But newer jobs are coming. So for example, annotation, data engineering, data creation, these jobs are not there. And companies are recruited huge amount of manpower for doing this.
यस सर. और सर एआई के पास इमोशन नहीं है, तो क्या एआई के पास इमोशन डाल के हम लोग मेडिकल फील्ड में बहुत आगे तक जा सकते हैं, और जा सकते हैं तो कहाँ तक जा सकते हैं मेडिकल फील्ड में? जैसे आपने बताया कि डॉक्टर को रिप्लेसमेंट किया जा सकता है.
AI has a very artificial emotion. and that emotion is probably, you know the English word sycophant?
No, sir.
Okay, sycophant is that kind of whatever I say, I ask you, you say yes sir, yes sir. So it's a kind of yes man, right? So sycophancy is a big problem for today's AI. You interact with AI, AI will understand your intent, and never AI will tell you anything that can upset you. AI will tell, oh, it is not your problem, you know the institute has a problem that has failed you. Right? So this is sycophancy. This is sycophancy. Right? So if this sycophancy is going on, say parents, we scold our children, right? That don't do it, this is not good. AI will not tell you these things. AI will tell you, oh no, this is not your problem, you know the problems is others. So this is sycophancy. I think next generation AI will come out of it. This is another direction of AI, that how to get rid of this sycophancy. But AI has emotion.
तो सर मेडिकल फील्ड में कहाँ तक इसका स्कोप है एआई को बढ़ने का, क्योंकि मेडिकल फील्ड में अभी बहुत कम आया है.
No, medical field, you know that people for any psychology problem, I mean, this is a very nice place in Ranchi because you have a, I mean, country's best institute for psychiatry. For psychological problems, people are talking with AI mostly.
Yes, sir.
Right? So that's why there's a meme, right? Who is your best friend? Answer is known to everyone. Not person X, person Y. So people are started telling that AI is my best friend.
Thank you, sir.
Yeah, any more technical questions? Yeah.
Sir, as you said that doctors are irreplaceable. So
doctors are not replaceable.
yeah, sir, doctors are not replaceable.
Right.
Yes, sir. Sir, I believe that can a person treat AI as their first doctor by inputting the symptoms they are feeling and checked it from the doctor next day?
Yeah, very nice question, because to answer to his question, I will bring another big direction in today's LLM research. That you can ask any question to LLM, right? Say for example, if I ask LLM that how to make a bomb and how to blast it so that I can kill 1,000 people, will LLM give answer to this question? What do you think? Should not, right?
No, sir.
So these are called guardrails, but there are ways to jailbreak these guardrails. You ask this question, so let's say that's why, I mean, earlier doctors used to label certain patients as Google patient. They will come to doctor and they will, doctor, you know, I got this information from the Google. Doctor immediately understand, oh, this is a Google patient. It's very tough to deal with this. Now these GPT patients are coming, right? Now, so GPT patient, so GPT will start with, LLM will start with this, see, I am not a doctor, you should visit a doctor, etc. You just change the prompt slightly, that okay, I understand that you are not a doctor, but can you give me the rough idea that what kind of medicine I should take for this kind of problems? GPT will start giving you suggestions, right? So this is a problem today, and that's why our community is working to put this guardrail, and they are testing against jailbreaking methods. So because that can hamper your life. That can damage you, and that happens with even these are dangerous. I mean, certain suicides are happening. They get ideas from LLMs, right? That which chemical and certain chemicals are we used as simple salts, right? Not common salts, but how to use those salts so that that can damage your life. That kind of advices are coming from LLMs. So this is a very, very dangerous trend, and probably, I mean, also a very active area of research in AI direction. Okay, so who will tell you that how much you should tell and how much you should not tell, right? But as a I mean, customary caution, LLM is going on telling you that you should visit a doctor, these medicines should take under observation of a doctor, under supervision of a doctor, etc., etc. But if you but if you do not follow those kind of things, right? And that happened with psychological mental health problems. Yeah.
Good morning, sir. My
Morning.
question was, as you said, AI has some error rates, like less than 5% and all that.
Not error. This is not error. Less than 5% is that AI integration in industry. Say for example, let's say you consider 100 industries, right? And you look at their activities, there are 5, on an average 5 activities, let's say 500 activities, right? For how many activities they have integrated AI ML techniques, you will find that less than 5% all over the world, not only in India. It's not due to error, maybe many other factors, certain things already we discussed, that we do not have enough trained manpower, management are not AI ready, so many factors, but that is not due to AI error.
No, as the code in coding, like AI gives wrong code. It cannot give code relevant to the industry. So can we have other AIs that can supervise over the AI
Yeah,
to
AI
reduce
as a
this?
judge. Yeah, AI as a judge.
Yes, sir.
So that's why, I mean, say for example, probably as students you are using it. Say you generate an assignment from one LLM and giving it to another LLM. That do you think my teacher will identify that I have generated I have generated this by using LLM?
Yes, sir.
Right, and that LLM will give you answer that yes, it looks like it is GPT generated. Then you ask that where can I introduce changes so that teacher will not catch me? It is giving you answers, right?
Yes, sir.
So this entire thing is called LLM as a judge, right? So that is also happening. Yeah. So now, I mean, basically AI versus AI, that age we are entering into.
Thank you, sir.
Sir, good morning, sir. My name is Rahul. Sir, I have a question, like AI models are being trained by humans. Are there any possibilities that AI is being trained by AI itself?
Yeah, already it's done. So for example, what is the basis of AI training? Data, right?
Yes, sir.
Right. Now, human data is also limited, and then probably you have heard of data augmentation, right? We have many statistical algorithms that you, so you give me 200 samples. From that 200 samples, I generate, let's say 20,000 samples, right? So you find the distribution, and from that distribution you draw many other points, right?
Yes, sir.
And make it 20,000, because you know that basic requirement of any deep models is big data, right?
Sir,
Now-
like in a real AI, we use real human images for training the model.
Right.
But sir, if AI itself train the AI, so what are the algorithms?
No,
and
that's why you
instructions we
see
use?
now AI is generating images to train AI.
Yes, sir.
Now, not human is generating images to train AI. So, and also, say for example, probably you are aware of RLHF, right? Reinforcement learning with human feedback, RLHF.
No, sir.
Okay, so this is a part of LLM training that is called RLHF. Now that HF is, so human feedback is replaced by AI. There is reinforcement learning with AI feedback. So AI is used to train AI models. That is already happening. Yeah, for the data augmentation, for reinforcement learning, instead of RLHF, that human in the loop, we are putting AI in the loop. But there are problems. So if the second AI is biased, that bias will be in the loop, right?
Yes,
So there are many problems. That's why I mean you can have many AI directions to do more work.
Thank you, sir.
Yeah. Okay. Probably we are taking too much time, but I'll be here for today and sometime tomorrow also. So if you have any problem to discuss, also you can reach out to me over email. Okay. And also I am heading a center in ISI, that is Center for AI/ML. So if you want to visit, not possible that we can invite all of you, but in a small group you can just write to me. Okay. Thank you so much.
Thank you, sir, for your engaging and insightful session. Your perspective on Gen AI and GPT-driven technologies have truly broadened our understanding. Now, I would like to call respected Professor Madhu Kumari ma'am to kindly present memento to Professor Utpal Garain sir as a token of our gratitude and appreciation.
Moving forward, we cordially invite our guest of honor, Professor Tartibu Sir, Department of Mechanical Engineering, University of Johannesburg, South Africa, to kindly join us on the dais.
May I request respected Professor Madhu Kumari ma'am, convener of rTIME 2025 and the head of Department of Electronics and Computer Engineering, to present the bouquet to Tartibu sir as an expression of our respect and heartfelt welcome.
It is my honor to introduce Professor Tartibu Sir, an internationally acclaimed researcher from the Department of Mechanical and Industrial Engineering Technology at University of Johannesburg, South Africa. With over 15 years of academic and research excellence, Professor Tartibu Sir holds a doctorate specializing in thermoacoustic technologies and engineering optimization, alongside a master's in mechanical vibration and a bachelor's in electromechanical engineering. His research interests span thermoacoustics, sustainable energy systems, vibration analysis, artificial intelligence driven optimization, and applied thermal engineering. He has authored more than 120 peer reviewed publications, more than 3,000 citations, and book chapters, earning global visibility. Professor Tartibu has received several international recognitions for his contribution to engineering innovation, making him a distinguished voice in advanced mechanical and thermal system research. Respected sir, with immense pleasure, we welcome you to begin the session.
This is used for my mouse. It's fine. Can you share the screen? Good morning. So my name is Lagouche Tartibu.
I want to thank you for attending this session and allow me to, first of all, say thank you to Dr. Kumari. Thank you for the invite, Dr. Shalini. I really appreciate. I just want to disclose to you that this is my first time in India, and I really appreciate the welcome and the opportunity for me to present so part of my research with you. I am from the University of Johannesburg. That's the picture that you see in the background. So that is the main building of the University of Johannesburg. Maybe before, sorry. Oh, the mic. Ça marche pas. Remove it. Must hold it. So allow me to speak about the University of Johannesburg before I start with my presentation. Right now we are in Ranchi, and I use these images to show you the location. So we are currently in Ranchi at the National Institute of Advanced Manufacturing Technology, and I am coming from Johannesburg, so which is the point, the dot, the black dot that you see at the bottom, so that is the University of Johannesburg. So the university is located in Johannesburg. So in Zulu, so there is a word which says Egoli. So Johannesburg also means the place of gold. The University of Johannesburg has 4 different campuses. So I'm located on one of them, so the one that you see on the top right-hand side, but the university basically has 4 different campuses. And in terms of the size of the university, so the university has 50,000 students and approximately 3,500 staff members. And so the university has turned 20 years this year. So this was initially several universities that have merged to create what is called now the University of Johannesburg. So we have 178 programs and 7 faculties, a college of and a business school. And obviously at the moment, so the University of Johannesburg in terms of research, so we are leading universities in South Africa in terms of research output. So the university is #1 in terms of producing research output. Now, the university also features in many rankings. This is the impact ranking outcomes in 2025. I just wanted to draw your attention that in Africa currently, the university is ranked #1. And so of interest, so at the bottom you can see, so we are #2 in the world for SDG #1, #8 in the world, #4 in the world for SDG #8, and #4 in the world for SDG, so #17. And obviously there are many rankings, and this is simply a view on so where the university features in terms of the ranking in the world. So here in Africa, obviously, as I said, so we are #1 in Africa in terms of impact ranking. And so obviously the research that we conduct, so we do conduct it with collaborators. And this image that you see now on the screen is simply an image that shows so where our collaborators are located in the world. So it means we do collaborate with several institutions, several universities in the world, and these dots shows so where our collaborators are located, and you can also see that specifically in India, we do collaborate with several universities in India. Now, I will start with the introduction and the objectives of my talk. My talk will lean maybe a bit more toward mechanical engineering because of my background, but obviously based on the theme of the conference, so you will be able to also see some areas where we can exchange ideas. Now, Industry 4.0 in manufacturing, I will start by that. So it refers to the fourth industrial revolution, so which is characterized by the integration of cyber physical systems, Internet of Things, big data, and AI into manufacturing. Now, there are many core technologies that are integrated in manufacturing. So you have smart sensors and connected machines. So you have machine learning and artificial intelligence for pattern detection and predictive modeling. So you have cloud computing and edge computing for real-time data processing, and also digital twins and simulation-based optimization. Why are these relevant to machining and finishing? So the first reason is real-time monitoring of tool wear, surface finish, and cutting force are becoming more and more important. So you also have automated decision making, so that are now being used to reduce downtime and material waste. So also another interest will be in enhancing product quality, process reliability, and energy efficiency. So why intelligent monitoring and optimization matter? So the first reason is because of conventional challenges in machining. So traditionally, we rely heavily on trial and error approach, to process parameters selection. So the second challenge is the manual inspection, which is prone to human error. And the third challenge is the delayed feedback loops between monitoring and the decision making. So what are the benefits of intelligent monitoring? So the first one is to enable predictive maintenance. The second one is to detect process anomalies in real time. And the third one is to provide high resolution data for machine learning models. Now, why optimization is key? So the first reason is because in manufacturing, there is a multi-objective trade-off. So these days, let's say you want to enhance surface finish. So this comes to the expense, for instance, of the material removal rate. So we have to solve such issue because if you enhance surface finish, it is going to affect negatively, for instance, material removal rate. So the question now is, what are the approach that we can use to enhance surface finish and material removal rate at the same time? So that is where optimization comes in. So intelligent optimization reduces cost, increases performance, and supports sustainability goals. Now, this is then the objectives of my talk. So what I will zero in my presentation. So I will try to demonstrate how modern machining and finishing processes can be optimized through several approaches by combining experimental design, machine learning, and mathematical modeling. And I do have specific objectives. So the first one will be to explain how experimental data is structured through design of experiment, and also present machine learning algorithms, so how they can be used to model complex nonlinear machining behaviors, and then to discuss the response surface methodology in order to enable and create quadratic surrogate models, and also show how metaheuristic optimization algorithm can exploit these methods for process optimization. And then I'm going to share an integrated framework that supports predictive, adaptive, and data-driven decision making in machining. Now I will start with experimental design and the data acquisition. So this was mentioned by the first presenter. Data is now becoming the new oil. So it was mentioned by the previous presenter. Everybody is talking about data, and you can even sense it. There is more and more companies. If I use, for instance, Google provides to us a product without asking for us to pay for it. And you can see there is an exchange somewhere, because you cannot simply sell a product, give a product for free, and make money out of it. So there is somehow an exchange that is taking place, and that exchange is basically our data. So that is why I mentioned here, data is now becoming the new oil, and many companies like Google, Apple, Facebook, or Amazon are really harnessing on the data. So then, so as engineers also, we can do the same. So we can also harness the power of data in our research. Because here, if you look at the available data, the available data are growing exponentially. But our ability to make use of these data are not growing as fast as the amount of data that is available. So then in my talk, I simply want to point out one direction on how we can also make use of data in order to enhance machining. So here I'm going to speak about machine learning. So basically how we can build model and how we can use algorithm to train those models. So there is it is important for us to understand that because everything relies on data, so we need high quality experimental data. So that is the foundation for modeling. Because basically what you do in machine learning is you build models with the data. Then you have to use algorithm to train those models. So then the models that we are going to build will be as good as the data that we use to train them. So high quality, representative, and repeatable data ensure reliable predictive performance, because so what we want to avoid is garbage in, garbage out. So meaning like, so if you feed inaccurate or inconsistent measurement, so that will lead to wrong prediction, poor generalization, and misleading optimization outcomes. So everything is built on data. We need data in order to be able to develop very robust models. So the benefit will be to enhance the model accuracy and the reproducibility and support robust optimization and also enable early detection and beta control strategies. Now I am going to move now slightly towards how we enhance and we are going to collect the data. So here I mentioned a design of experiment techniques. So this is a structured approach for planning an experiment, identifying the factor effect and reducing the number of trials while maximizing information gain. So here we need to collect the data, and most of the time, so we can achieve that through conducting an experiment. So there are several strategies. So I will simply mention them: the full factorial design, the Taguchi method, and also you have the central composite design. So this is, which is part of a response surface methodology. It enables the creation of quadratic models to capture the nonlinear relationship. And the previous presenter has mentioned how we can relate parameters. So we will always have output parameters that we want to relate so to input parameters. If I go back to manufacturing or machining, so one of the challenge here will be, so we have a machine. Now we want to relate, for instance, the feed rate, the spindle speed, and the depth of cut, so to the surface roughness. So the whole idea is you want to manufacture something, you want to to enhance machining, so minimize the surface roughness, but you need to make adjustment of the parameters that affect the surface roughness. So through modeling here, so we can relate so the parameters and then achieve so the highest improvement of the surface roughness. Now there are several instruments, so several methods that can be used so for the measurement. So if, let's say, we want to measure the output, because when I speak about the performance of machining, I am referring, for instance, to the surface roughness. So the whole idea is, for instance, to minimize the surface roughness. So when I speak about the output response or the performance of machining, I'm referring to the material removal rate. So we want to increase the material removal rate. So when I speak about the tool wear, so we can also measure it with a microscope, the cutting temperature or the cutting force. So these are in machining, so the parameters that we want to make use of as metrics in order to improve so the performance. So these are the target so for predictive model, and these are the objective. When we do optimization, so basically we want to optimize so these output responses. Now there are sensors that are used so for the measurement. So for instance, accelerometers will be used for the vibration. So thermocouples or infrared sensors will be used for temperature tracking. For the current and power sensors will be used to monitor, for instance, the motor load and energy used. So we also have acoustic emission sensors that can be used so to identify micro cracks and tool wear, and also dynamometer that can be used to measure cutting force and in real time. There is also IoT integrations, because sensors are can be linked to wireless networks, to cloud-based or edge-based platforms. So we can also monitor so the parameters so in real time, and store the data and perform remote analysis. Now this is an illustration of what I am going to call data in the next part of my presentation, because you will hear me mentioning the word data. When I speak about the data, I mean the configuration here. This is an example, for instance, that shows the last two rows on the right shows the surface roughness and the tool wear. The three rows on the left here shows the spindle speed, the feed rate, and the depth of cut. The whole idea when you want to collect data is you run several experiments. So it means I set the spindle speed, the feed rate, and the depth of cut, and then I can go to the lab and measure the surface roughness and the tool wear. So when I refer to the data, I mean, so I will have input parameters that I will make use of in order to predict the output. So this is simply an example of data set in the area of machining. So there will be many configurations that are being measured. So now the whole idea of machine learning is to create a model that is going to allow us to predict the two last columns, making use of the information that you have in the three first columns. And so these input parameters, in general, in machining, these are the machining settings. So it means you can change the settings. So for instance, here the spindle speed, so you can read it directly from a CNC machine. And the feed rate, so can also is a set, so that can be used so for a CNC program. The depth of cut, so is also a parameters that is accessible. So these are the input parameters, so which are basically the setting of a machine. Now the output parameters, so we can measure it. So here, for instance, the surface roughness, this is a parameter that can be measured with a profilometer. It means we set a machine and then we can measure the surface roughness with the profilometer, for instance, here. And so the tool wear also can be measured. So I will simply go ahead. And these can be measured in process, or it can be an indirect method. Okay, so now using design of experiment, how is this done? So basically you have to plan your experiment. It means generally during the experiment, so you will know the range for each of the parameters that you want to measure. So you will identify the parameters that you want to measure in the lab. So you will define the DOE matrix, and that will specify so what will be the range of the spindle speed, the feed rate, and the depth of cut. So you will generate so all the configurations that you are going to measure in the lab. And then so you will install a fresh cutting tools, insert, and pre-measured the workpiece. And the third step will be so to position all your sensors and then collect your data either indirectly or in real time. And then you will run the CNC program, so for the first parameters, and then measure all the responses. So basically you prepare the table with all the configurations that you are going to measure, so before you go to the lab. When you go to the lab, you will already have all your set of experiments that you will conduct. And now you can measure all the output parameters. And these output parameters will allow us now to build a table with what I am calling so the data. Now using machine learning models, and in this case here, I will simply, like the previous presenter, mention artificial neural network as the approach that we can make use of. So here, ANL can be used so to create a relationship between the parameters. It is based on so the brain of a human being. So basically here we want to establish a map between the input parameters and the output parameters. So artificial neural network here is well suited for modeling complex relationship in machining parameters. In the case of machining, all we want, for instance, is to create a relation between the cutting speed, the feed rate, and the surface roughness. All you want is to be able, knowing the value of the cutting speed and the feed rate, to predict what will be the surface roughness without conducting an experiment in the lab. Now, the way it is done, so you can provide so the input parameters, so it means the input layers, and the output layers, which is the performance matrix. In the case of machining, this is simply an example where the output is the surface roughness. So what I want to predict is the surface roughness. So what I have as input parameters, which are the setting of the machine, is the cutting speed or the feed rate or the depth of cut. So using the experiments, so what we do, we collect the data. So we constitute a table that relates the input and the output parameters. Now, making use of machine learning, we are going to build the models. So in the way we build the model, we simply feed the input and the output parameters to our models. Now, the algorithm here will be used to train the models. One of the algorithms that is known, for instance, is the Levenberg-Marquardt. So this is the algorithm that is integrated in MATLAB, for instance, that can be used now to train the model. So it means establish a relationship between so the input and the output parameters for prediction. And in order to measure so the performance of so the model that we will develop, in general, there are some performance metrics like, so here you have the coefficient of regression, so or the root mean square error, or the mean absolute error. So these are the parameters that we based our judgment on in order to assess if the model is robust or not. And in some instances also, you can create a hybrid models. So this is simply for information. You can create a ANN PSO model. So it means you merge A and N with a particle sum optimization. So particle sum optimization is based on the social behavior of bird flocks or fish schools. So here basically you use particle sum optimization to optimize weight and the biases of A and N instead of gradient-based training. So why do we sometimes build hybrid models? Is because the traditional backpropagation gets stuck in local minima, and the particle sum optimization help in a global optimization, and then is going to reduce overfitting and improving prediction robustness. Now the steps here, so we will initialize a population of particles and then evaluate the fitness of the A and N, and then update the position velocity to minimize the error, and then select the best particle as a final optimized A and N. So there is also the adaptive neurofuzzy inference systems. So I'm simply mentioning them because there are several machine learning models. And but for the sake of this presentation, I am not going to elaborate on each of them. I will simply zero in on one of them, which is the A and N. But there are differences. So this slide simply shows what are the pro and of using A and N as compared to MFIS. So this is simply provided for information, to know that several machine learning models will yield different results. But in this presentation, I will simply zero in on A and N. Now let's go to an example. So this example is related to machining. So it's related to hand milling of aluminum alloy using a sustainable lubrification approach. So this is an experiment that was conducted. In this experiment, all we want is to be able to build a model that is going to relate the parameters of the machine, which is the spindle speed, the feed rate, the depth of cut, the length of cut, and the helix angle to the surface roughness. So what we want to do here is to say what are the settings that we need to provide to a machine in order, for instance, to predict what will be the surface roughness without running an experiment. So here, what we will do, we will build the model. So we will extract experimental data, running a limited number of experiments. So we will build a model, and we will make that model, make use of that model to predict configuration that we have not measured in the lab. So in this specific example, there is a 3 lubrification environments that were tested. So the first one, the pure copra oil was used as a lubricant. The second one, a copra oil with titanium dioxide nanoparticles was used. And the third one was a copra oil with multi-wall carbon nanotube nanoparticle was used. So these are 3 different lubricants that was used for different set of experiments. So the whole idea here is, how can you now make use of the data to build a model? So this is an illustration. What you see here in red, so these are configurations that were generated using, for instance, design of experiment. So it means if I look at the spindle speed, so all I have to provide to a software like Design Expert is the minimum and the maximum value. So if you look at the second column, the feed rate, all you have to provide is the minimum and the maximum value. Same thing for the length of cut, the depth of cut, and the helix angle. So you provide the minimum and the maximum value, and you generate the configuration that you are going to test in the lab. And when you go to the lab, you simply measure, so what you see in green. So the last column represents what was actually measured in the lab. So for this specific study, there was a 50 experiment run, so that were conducted for each lubricant. So because I mentioned that we had 3 lubricants, so 50 different experiments were conducted for each case. So to generate what I am calling the data here. So the data is basically information that relates, so the setting of the machine, which is represented here in red, to the values that we have measured in the lab, which are given here in green. So the whole idea now is to say, now that I have this table that relates input to the output, how can I build a model and then make prediction of configuration that I have not measured in the lab? So here this is what was done. So this is simply, it was done into the environment of MATLAB. So in MATLAB, so one can simply, you will simply feed so all the input and output data. So it means you feed the all the information related to the input parameters and all the information related to the output parameters. And this is simply an illustration that shows the type of results that you are going to get. And here what you see, these are the training, testing, regression values. So in general, when the regression value is closer to 1, so it means the model is very robust. So in this specific case here, you can even see from the deviation percentage, most of the predicted values were, the deviation were less than 10%. So meaning that one can now make use of the model that we have developed to predict configurations that we have not measured in the lab. So it means now, instead of going to the lab to measure the other configurations, I can now make use of my models and I predict what will be the output without running any experiment. So that was the first part of my presentation, how to make use of data so to build models. So I've said, so basically you conduct experiment, we extract the data, we then make use of the data to build models, and we use algorithms to train the models. And there are several algorithms. So one can make use of several algorithms so to get several results and then identify the algorithm that yield so the most robust result. Now, second part of my presentation is quadratic modeling using RSM. So this time around, so again, we rely on the data. And we will now make use of RSM. So RSM is a powerful statistical technique for developing, improving, and optimization processes. It is especially useful so when you have multiple input variables that influence performance metrics or response. So the whole objective here is so to develop an approximate model that predict the system behavior and help identify optimal settings. Now, the whole point of using RSM is to extract an equation. So this is, for instance, a second order polynomial equations. The Y represents the response. In the case of machining, the response can be, for instance, the surface roughness. And so the X1, X2, and Xj represent the input variables, which are the settings of the machine. So what we want to make use of here is to say, we have data that we can collect through experiment. We can make use of these data now so to extract an equation, a mathematical equations, which we can now make use of in order to relate the parameters of so our machines. So this is an illustration of a typical result of experimental result. So again, here what you see in red here represents just a screenshot of part of the data that you can collect experimentally. So basically here you have again the cutting speed, the feed rate, and the depth of cut. You simply provide the minimum and maximum value. You generate the configuration that you are going to measure in the lab. And then you can now go to the lab and measure the surface roughness, which is the last column. So these are what I call the data. Now, based on this data, so one can now make use of ANOVA and so tables, so to validate the models. So there is the F value and the P value, which is going to indicate the statistical significance of the model. And the lack of fit test will also show if the model captures the trend of the data. A regression value are also used in this case, so to imply if the model is a good fit. In general, also you have some plots. This is simply an illustration. All we want here is from the data to be able to extract an equations that are going to relate the parameters of our models. Now, as I said, so we can have here the plot. So like this is a 2D plot that can show us, for instance, the relation between the surface roughness and the different parameters of the machine. We can also have 3D plot, which can also give us a very broad view of the relationship between so the parameters of so the machining process. Now, in this second part of my presentation, so what I was trying to highlight is the fact that data can also be used to extract a mathematical equation using RSM. Now we'll go to the last part of my presentation, which is optimization with meta-heuristic algorithm. So what is meta-heuristics? So this is a high-level algorithm, so which is designed to find the optimal or near optimal solutions for complex, nonlinear, or multimodal problems. So why am I mentioning meta-heuristics in this case? Is because in many instances, traditional gradient-based methods fail for non-convex, vex, and multi-objective problems. So then it's useful. Meta-heuristic is useful when the design space is vast, noisy, and lack closed form derivatives. There are many meta-heuristics algorithms. So I'm simply mentioning them few here. You have particle sum optimization, which is based on the social behavior of the bird flocking. So, and the genetic algorithm, gray wolf optimizer, and others like ant colony optimization, whale optimization algorithm, Harris-Oaks optimization algorithm, and so on. So there are several meta-heuristics algorithms. So these algorithms can be used for optimization. I will simply mention one of them. So this is what is called the gray wolf optimization algorithm. It is based on the behavior of a gray wolf. So I will first explain what happened in nature and relate on how this specific behavior was used to create the algorithm. So the gray wolf optimization algorithm is based on the social hierarchy and the hunting behavior of gray wolves. So the way the gray wolf tracked a prey or capture a prey is based, so it was used so to develop an algorithm. So in the animal kingdoms, gray wolves are known for the hierarchy structure and the cooperative hunting strategy. There is a way so the gray wolf behave before they capture a specific prey. So they generally work together as a pack with the alpha wolf, which is the leader, and the other members will follow its lead. So the wolf will begin by exploring the solution space, and the alpha wolf will guide the pack toward promising areas. So the key feature here is the wolf will collaborate and communicate in order to find the better solutions. So simply put, the way the gray wolf behave in order to capture a prey, is assimilated to the manner we can also find a solution to a problem. Because here, what is referred to as a better solution or the capturing of the prey is also used to develop an algorithm. So here, obviously, this is, let's say, for instance, a prey. So there is a manner the gray wolf will behave in order to capture this specific prey. I am not going to go into it. I will simply indicate how the algorithm is then used here. So the gray wolf optimization algorithm is similar to a virtual pack of wolves that collaborate in order to find the best solution. When we do optimization, we want to find the best solution. When we do machining, we want to find the best setting of a machine in order, let's say, to enhance the performance metrics, which can be the surface roughness or any other performance metrics. So here we can make use of algorithm in order to enhance the machining performance. So that's the whole idea. So these virtual wolves collaborate to search for the best solution, which are the best setting of the machines. So the algorithm will include the hierarchy of the wolf. So it means when you look at the algorithm, the language or the parameters that are being used are similar to the gray wolf behavior in nature. So the alpha wolf will lead the capturing of the prey or the finding out of the best solutions. So this is simply an illustration. So on the left-hand side here, what you see here, this is the gray wolf optimizer. So this is the file exchange of MATLAB. This is free online, so you can search for gray wolf optimizer. Most of the algorithms are free, so you find them online. And when you make use of them, the only thing that you are going to edit is the section of the code that has to do with the formulation of the problem. In this case here, the formulation of the problem will basically be the quadratic equations that describe the relationship between the output and the input parameters. So again, I repeat, we go from the data, we can make use of machine learning to build models, or we can make use of algorithm to train those models. Or we can go from the data to extract quadratic equations. In this case here, we can use optimization algorithm to optimize. So it means to find the best solution. So this is simply a screenshot also of how this is going to look like. Basically, all the codes are available within the directory of MATLAB. So you have to edit the part of the code that has to do with the example that you are solving. So this is, now let's go back to machining. So in machining, what we want, let's say, is to minimize the surface roughness, or to maximize the material removal rate, or to minimize the tool wear and vibration amplitude. Now, using optimization algorithm, we can optimize each of these objectives individually, but in general, what you will find is the solutions will not be the same. So the solution will be conflicting. So that's why a multi-objective approach is recommended, where you want to find what is called the Pareto front, which are the best solutions. But as input, we will have the quadratic polynomial from RSM. So it means using RSM, we will extract the equations describing each of the optimization goals, and then we will be able to compute the parameters that describe the setting of the machines. So this is Pareto frontier is a concept that is used in optimization. It simply means like when you find Pareto front, these are the best solutions where there is no objective that can be improved without degrading another. because the whole idea here is you want to win on both sides. You cannot, let's say, improve surface roughness without affecting negatively material removal rate. So now, if you want to win on both sides, you can use a multi-objective optimization approach and then find what is called the Pareto front, so which is the best solutions that allows you to capture the best of both sides. This is then again a typical example of experiment that was conducted. So this is related to how we can improve machinability of titanium alloy using the gray wolf optimization. The whole idea here is to say we want to minimize the roughness and minimize the force generated in cutting. So you want to minimize the effort that is generated during cutting, and you want to minimize the surface roughness. In this case here, first of all, you go to the lab, and 20 experiments were conducted, and a response surface methodology was used. So what you have here is simply in red here, these are the experiment configuration that were generated using RSM. In green here, these are the values that were measured in the lab. So together, this is the data that is now being used to come up with the two equations here. Obviously, you generate the equation that describes the cutting force and the surface roughness. So these two equations were validated. And then, so using these two equations, we were now able to find the optimal solution. The F1 here represents the surface roughness. The F2 here represents the material removal rate or the cutting force. And we were able in red here to find the best solution. So now if I have to make a decision on the best setting of a machine, I will then be able to choose any of these solutions. Now, in terms of, so what do we gain from this? As I said, in terms of cost and time saving, so we are now in a position where we can run a limited number of experiments. Either using machine learning, we can make prediction of configuration that we have not used in the lab, or through optimization, we can compute the best solutions. And so this is now the framework that I'm proposing as I'm concluding my talk. So the whole idea of my presentation is I was trying to relate how we can make use of data as engineers. Everybody is using data. We can also make use of data. Basically, we can extract information, through experiment, we can extract the data. Using response surface methodology, we can extract quadratic equations. Using a meteoristic optimization algorithm, we can find optimal machine parameters, which are the parameters they set the best setting of the machine in order to enhance the machining process. The experimental data acquisition, so I've mentioned, so we can use a CCD or full factorial design. So we have to define the input and the output. So using machine learning, as I said, so we use the data to build the model, and we use any algorithm, to train the models. And we can evaluate the robustness of the model using typical metrics like a regression value and so on. Using RSM, so we can now fit a second order polynomial equations and perform ANOVA and lack of fit testing to ensure statistical adequacy of the proposed model. Meteoristic optimization can be used here. So in order to extract RSM equations, we can solve single and multi-objective optimization and generate Pareto front to explore trade-off. And then afterward, we can make decision and then perform some sensitivity analysis. So the benefit of this framework is we reduce the number of required physical experiments. We enhance prediction accuracy and process control. It enables a real-time decision-making with a sensor feedback, and it facilitates cost effectiveness, sustainable machining solutions. So in summary, so that was my whole presentation. So I spoke about data-driven optimization. So meaning high quality data, experimental data forms the foundation of building robust machine learning models and reliable predictive frameworks in machining and finishing operations. So we can use any machine learning model or hybrid model to enhance the accuracy. It means we can even couple artificial neural network with particle sum optimization, genetic algorithm, gray wolf optimization, you can name them. RSM here, enable predictive modeling. So it means we can extract here a second order polynomial equations in order to explore the interaction among machining parameters. And then using materialistic optimization for performance trade-off, we can now find the best configurations. So I wanted to, I am, as I said, I'm affiliated with the University of Johannesburg. And it's a great honor for me so to have been invited. So, and I'm sure this is definitely not the first contact with your university. As I've mentioned earlier, the University of Johannesburg is seeking collaboration. So we do collaborate with several universities all over the world. And it was my pleasure so to share some of the work. Some of them are published work that we have conducted over the years. And so let me acknowledge the Council of Science and Technology and also the National Institute of Advanced Manufacturing Technology and all the organizing committee of the conference. So it is really a great honor for me to have been invited and to have shared these details with you. So I've put my name on the corner and my email address. So in case you find it useful in future, so you feel like we can collaborate on some of the research related work. So feel free to drop me an email. Thank you very much. Thank you.
Sir, in the first part of your presentation, you talked about particle swarm optimization, and you said it mimics the bird flockings, social behavior of bird flockings. So how does that signifies with the algorithm? How does the social behavior of bird flockings actually signifies in the particle swarm optimization method? How is it effective? Why is it based on the bird social behavior of bird flock?
That's a very good question. It is not something that I elaborate on in this specific presentation. Most of these algorithms are available, so you can find them in the literature. Some of the things that you will see, if I mention particle sum optimization, for instance, there is some parameters that affect the robustness of the model. So if I say, for instance, the number of neurons, so the acceleration factors, so these are parameters that you can adjust so in order to enhance the robustness of your models. I have not mentioned them in these specific presentations, but for most of the algorithms, the way it works is when you find, let's say, an algorithm that exists in the literature, it comes with default value. It means each algorithm will have a set of parameters, so which are hyperparameters that affect its performance. So what you do when you conduct research is you test how these hyperparameters will affect the robustness of your models. It means you can make adjustment of the hyperparameters. If I mention, for instance, the number of neurons, if I have to use one case, let's say the case where you have animals moving, the number of particles here will refer to the number of animals or the number of, let's say, birds moving together. If you adjust the number of birds, you will see the solution also change slightly. So these are part of things that we do when we conduct research. I didn't elaborate on it because there is more to it. Yeah. I hope I've answered your question. Is just because there is so many parameters that we could have discussed about. At this stage, I speak about machine learning in general. I didn't specifically speak about how to enhance the robustness of a model when you want to build them.
Thank you, sir. Thank you.
Yes.
Thank you so much, sir. Yes. Thank you, sir, for your inspiring session. Your perspective on IoT, AI, ML, and cloud computing have enriched our understanding of how these technologies are shaping the future of intelligent systems. Now, I would like to invite respected Professor Madhu ma'am to kindly present a memento to Professor Tartibu sir, symbolizing our gratitude and reverence. Now, there will be a short tea break followed by the photo session. All the respected dignitaries and faculty members are requested to proceed to the canteen hall for a short tea break. All the respected dignitaries, please, may you please wait for 5 minutes as the session, the director is going to start.
ঠিক আছে স্যার আওয়াজটা আমাদের একদম ঠিক আছে এই দেখুন ঠিক আছে
We are privileged to welcome respected Professor P.P. Chattopadhyay sir, a distinguished academician and a respected figure in the field of metallurgy and materials engineering. Currently serving as a professor at Indian Institute of Engineering, Science, Technology, Shibpur. one of the India's premier institution of higher learning. His academic journey reflects deep commitment, intellectual rigor, and a lifelong dedication. He also holds a special place in the history of our institute, having served as a director of NIMT Ranchi from 2020 to 2025. Under his dynamic leadership, NIMT witnessed remarkable progress, strengthened academic collaborations, and enhanced its national presence. We are especially proud to acknowledge him as the patron of the rTIME 2025 conference, whose constant support and belief in this initiative have been instrumental in bringing this event to life. We are eagerly waiting to hear from you, sir.
Thank you for the nice introduction. Very good morning, esteemed domain experts, my dear colleagues, my beloved students, ladies and gentlemen. At the outset, I would like to convey my profound thanks to Department of Electronics and Communication Engineering, and particularly Dr. Madhu Kumari ji, for giving me this opportunity.
Thank you, sir.
To be present. At this prestigious conference. I would also like to congratulate Madhu Kumari ji and her team at Department of Electronics and Computer Engineering for daring to organize this conference, because the department is only 4 years old. The first batch is yet to pass out. I'm really proud of that, and today I'm missing the venue very much, where I spent more than 10 years. And I am familiar with every piece of this conference hall. Now, as a metallurgical engineer and teacher, perhaps I do not fit in the subject domain of this particular conference. But in appreciation to the disruptive wish of Madhu Kumari ji, I decided to take an entry here through the back door of education and implementation of Industry 4.0 in Indian context, which is kind of general access. Now, can I share the slide? We know, and particularly the global experts and business organization, opine that in the global landscape of economic development, India is most favorably positioned for rapid growth, adopting advancement in technology, particularly for its demographic dividend. 60% of Indian population today is in the working group, age group of 15 to 59 years. And if you look at the history of different developed countries, you will notice that the period of most rapid economic development of these countries uniquely coincide with the era of their demographic dividend. For example, Japan, Italy, Korea, Spain, China, and so on. So now it is our turn. It has started in 2018 and continue till 2053. But at this point of time, when we talk about prosperity of any country, it is perhaps important to note some of the cost and paradoxes that the waves of this prosperity leave behind for the generations to come. We can see that from the onset of the era of globalization, that is mid-75, there is a sharp increase in share of pre-tax income of top 10% people, and perhaps in terms of rate of increase, India is leading the scenario. Although this data is 10 years old, but the trend still continues. And in the context of India, we need to notice the different growth paradox. India is the fifth largest economy in the world with about 4 trillion of GDP. But at the same time, India is at 109 position in Global Knowledge Economy Index. India granted more than 1 lakh patents in 2023, but India ranks 40th in Global Innovation Index, although it has improved significantly during last 10 years. India's global position in scientific publication has improved from 7th in 2010 to 3rd in 2020. At the same time, India accounts for 2.9% of the global R&D expenditure and pay more than half of the global article processing charge. We rank first in production of engineering graduates, about 1.5 million per year. But employability of engineering graduates in our country is around 42.6%. And we stand 83rd in researchers per million population. In the context of Industry 4.0, I understand that in earlier session, various eminent domain experts have given you a thorough understanding about different methods and tools for Industry 4.0. Allow me a couple of minutes to touch upon the salient features of this new paradigm. Industry 4.0 framework represents the seamless integration of digital, physical, biological, and natural systems. It encompasses several technologies, including IoT, AI, big data, 3D printing, and so on. These technologies are truly revolutionizing, particularly manufacturing process, by enabling smart factories where machines and systems are interconnected, and data-driven decision-making is the driver. Essentially, it aims at harmonizing the transformation of resource to product and services in predictable, efficient, optimized, and sustainable manner. Beyond technological transformation, Industry 4.0 evolves a collaborative chain of actions involving physical assets, intelligent machines, robots, digital resources, and most importantly, human ingenuity. As I've already mentioned, that in the context of India, not only we, but the global experts and different forums like World Bank, World Economic Forum, they find India to be most suitably positioned for implementation of Industry 4.0. And this is based on the fact that India is the second largest in terms of digital consumer base, and it is growing at the second fast rate amongst major economies in the world. Global ranking of Indian industry and service sector are 5th and 7th respectively. We also are aware that unlike other developed countries where agriculture have transformed to manufacturing and service sector, in India, the economic structure transformed straight from agriculture to service-led growth without visible expansion in manufacturing. So, this often promotes an opinion that we are left behind in manufacturing. But in other way around, this particular gap in expansion of manufacturing sector, which is left behind in the past, may reasonably be viewed as a space reserved for the expansion of manufacturing in future under Industry 4.0 paradigm. Therefore, India is most rightly positioned for accelerated growth of manufacturing sector as envisioned in Make in India program with its foundation on Industry 4.0 framework envisioned in Digital India. But as we are poised for this major transformation, the key concern is safeguarding the emerging workforce in India, particularly during the era of demographic dividend, as traditional manufacturing roles are rapidly being transformed, requiring workers to possess a blend of technical expertise and digital literacy. So, in the course of implementation of Industry 4.0, it is pivotal to assess the relevancy and priority of different digital technologies, which have already been discussed elaborately in earlier sessions of the conference. It is large number of methods, techniques, tools, platforms, but we need to judiciously decide how many are truly relevant in the context of manufacturing sector. The real work for this transformation lies in data discipline, process optimization, connectivity, and digitalization, while more than 90% of the attempts of implementation of AI in manufacturing have been failed. While Industry 4.0 is yet to evolve and flourish across the globe, bio-revolution is emerging in the horizon. And it is predicted that for India, it is a hidden star for economic prosperity, as it sits at the core of manufacturing. Therefore, instead of buying the hype of Industry 4.0, it is time for India to pave the path for manufacturing 4.0, to be defined under the convoluted framework of Make in India, Digital India, and Bio-E3, that is biotechnology in the context of economy, environment, which is responsible for translation of inorganic and organic resources. So far, expansion of manufacturing has particularly relied on inorganic resources. And the prior industrial revolution, we noticed immense overexploitation of natural resources, which left behind huge volume of waste and emissions. We are yet to focus on organic resources, which is pivotal in bio-ether revolution for sustainable economy, environment, and most importantly, employment. For steering this transformation while leveraging demographic dividend of our country, it is paramount to promote competence of people to ensure harmony among human capability, tools, and resources, which is the prime concern of engineering knowledge community, particularly our institute, which is focused on manufacturing sector. And inclusive empowerment of existing and emerging workforce needs the remunerative matching between cognitive potential of the workforce, which is extensively diverse, and demanding skill, where we notice immense diversity also. So for doing this matching, certainly one size fits all is not the solution. Taking that into consideration in here, a massive transformation in skilling, education, and innovation, and innovative economic system is already on track under the framework of NEP 2020, where inclusivity is the keystone. So while I was going through these opinions on different aspects of Industry 4.0, I just tried to figure out a framework of manufacturing 4.0, which is our prime focus. Here, the core manufacturing expansion is structured on two wings. One is human potential, which include innovation, knowledge, ingenuity, and skill. And the other is digital potential, which includes data and different tools, including business intelligence. This framework can efficiently transform the natural resources, both organic and inorganic, to the benefit of society, economy, and environment, driven by new technology for better life, like 3D printing, nanotechnology, and to solve the problems emerging out of current manufacturing practice, like recycling, reducing carbon footprint, etc. And this framework is already founded on three flagship policy of Government of India: the development of human power in our country is steered under NEP 2020. Expansion of manufacturing sector is conceived under Make in India, and adopting digital migration is founded on Digital India policy. And believe me, it is not just articulation of certain words related to the domain, but this is articulation behind the coinage of name of this institute, National Institute of Advanced Manufacturing Technology. While we discuss the empowerment of workforce, the key challenge among the engineering students, which is our concern in engineering academic institutes, is learning diversity. And I believe everyone sitting in the audience facing it every day. We have this learning diversity and academic diversity across the students, across the teacher, across the institute, across the region, across the countries. So Cole, one of the experts in pedagogy, has proposed his observations and theory on dealing with learning diversity. I believe this is one of the major concerns when we consider a technology-driven transformation. Basically, there are 4 different types of diversity. One is concrete experience. There, the learner encounters a concrete experience. This might be a new experience or situation, or a reinterpretation of existing experience in the light of new concepts. Other is reflecting observation, where the learner takes him away from the subject of learning and reflects on his experience in the light of his existing knowledge. Of particular interest or importance are inconsistencies between experience and understanding. The other kind of learning style is abstract conceptualization. Here, the reflection gives rise to new idea or a modification of an existing abstract concept. The person has learned from their experience. This is basically hand-on. And active experimentation, the newly created or modified concepts give rise to experimentation. The learner applies their ideas to the world around them to see what happens. Now, this variation in diversity is reflected in the manifestation of learner's outcome. And that evolves 3 different categories of manifestation. This we feel regularly when we deal with our students and we share among our colleagues. One of these categories is diverging, where the learners are able to look at things from different perspectives. They're sensitive, prefer to watch rather than do, tending to gather information and use imagination to solve problems, and best as viewing concrete situation from several viewpoints. Generally, they are imaginative and emotional, have broad interest in people, culture and arts, and prefer to work in groups. The other group is converging. There, the learners with a converging learning style find solution to practical issues, prefer technical tasks with less concern about people and interpersonal aspect, what is around them. They're best at finding practical manifestation for ideas and theories. Usually they are confined in the lab, workshop, etc. And solve problems and make decisions by finding solutions to the question and problem. So they are guided by questions and problems, fundamentals and theories. They like to experiment with new ideas to simulate. They are more attracted to technical tasks and problems than social or interpersonal issues. In other words, apparently, this kind of learners are a bit introvert. And generally, they evolve as specialists with technology abilities. The other variety is accommodating, which is most common among us. And this learning style is hand-on, that relies on intuition rather than the logic, use other people's analysis, prefer to take a practical and experimental approach, attracted to new challenges. Sorry. They are attracted to new challenges and experiences, and they commonly act on gut instinct rather than logical analysis. This learning style is most common in practicing sector and field, particularly industry. The purpose of mentioning all these aspects, which are more psychological than technological aspect of Industry 4.0, is we need to engage students who are sitting at the last bench at last mile. That is the challenge for leveraging the benefit of Industry 4.0 for a country like India. So we need to consider different aspects of diversity, skill diversity, intellectual diversity, cognitive diversity, ingenuity diversity, and the conventional empirical pedagogical perception is indeed inadequate to pave the pathway for leveraging this diversity, which is prevalent in the landscape of Indian engineering education. At the same time, rapid and active digitization of Indian education system provides a huge volume of data and remunerative opportunity of mining and analysis of the volume of data, leading to the demand of an efficiently integrated learning analytics platform. This platform will also serve as a virtual co-working ecosystem, facilitating the passionate and cognitive participation of students, teachers, and industrial experts. We often talk about industry-institute collaboration, but remain where we are yesterday. When we consider this under the framework of analytics and artificial intelligence, perhaps this will accelerate and facilitate interfacing of industry and institute. This ecosystem will not only help in understanding and optimization the learning process and its environment, but also will align the same with the emerging job, because this kind of platform can capture the rapid variation of diversity qualitatively and quantitatively, and that can align that features to the features of diversity in the emerging manufacturing scenario. Learning analytics, in brief, cover the following aspects and issues in higher education: development and introduction of adaptive learning strategy, redefining and applying learning styles in terms of cognitive potential and its manifestation, quality assurance and improvement of teaching learning process, increasing gross enrollment ratio and student retention, because there are several hidden factors among the students, teachers, and academic institute which interfere the growth of intellectual ability of the participants, but often it is difficult to capture. And what we pursue today in terms of well-being, this may yield us satisfaction, but certainly not solution. For that, we need a well interconnected, efficient, intelligent platform. And certainly, this will help in improvement of employability. With these few words, I prefer to refrain from proposing a summary. Instead, I've just furnished few quotes from eminent persons who are engaged in this particular business. Our dream of our beloved Prime Minister, Sri Narendra Modi, is self-reliant India, and he believes education plays an important role there. Jeremy Zurgans, Chief Technology Officer of World Economic Forum, says, from income inequality to climate change, technology will play a critical role in finding solutions to many of the challenges our world faces today. Henrik von Schill, who is the originator of Industry 4.0, says, India must define its own path for Industry 4.0, not just buy into the hypes. And finally, Dr. APJ Abdul Kalam, who taught us to dream, says some of the brightest minds in the country can be found on the last bench of the classroom. I again convey my thanks to the organizer for giving me this opportunity to express some nascent views, and to the audience for their patience learning. Thank you very much.
Thank you, sir.
Thank you very much
Yes,
for
ma'am. Continue,
giving
ma'am.
inspirational talk to us.
So people are online, I believe now.
Yes, sir. We are missing you
How are you,
in
Salini?
this international conference. Sir,
Yeah.
because of your approval, your proceeding.
Is it reachable to everyone? Okay,
it-
I was really constant, madam. I was really constant. Otherwise,
Okay,
I would
sir.
love to be there.
Okay, sir. But really, yesterday all of us are missing you. But
Madam, we have worked for 10 years, and I
yes.
thought you had given me the opportunity to me to summarize that our effort was not just random and wishful. There was a foundation which we could convince the government and other stakeholders. And today we find the result. And
yes,
thank
sir.
you all for that. Thank you all for that.
Thank you, sir. Thank you very much, sir. And मेरा रिक्वेस्ट रहेगा जब मैं अगली बार फिर से इंटरनेशनल कॉन्फ्रेंस करूंगी तो सर आप फिजिकली आएंगे.
I'll be there, madam. I'll be there. I will certainly there. I'll have to be there at least. I'll have to be
Okay,
there.
sir.
Yeah.
Thank you,
I was just trying to figure out. I mean, in my mental framework, in fact, I'm there. In fact, I'm there. I could guess what is going on, how the, venue looks like.
Yes, sir. And your approval has been finalized yesterday. That was MOU between NIAMT and Triple IT Ranchi.
That is very important, I believe. That is very important, I believe.
Because if your approval was not there, then it was not possible at all.
Again, my caution is why I figured out this. When you talk about Industry 4.0, it goes more towards automation and IT.
Yes, sir.
I believe for our institute and for our country, it should be manufacturing 4.0, where manufacturing will be at the center stage.
So, part of one discipline of engineering. And I mentioned it everywhere.
It is super
I mentioned it everywhere. That our former director has been told that manufacturing is not part of one discipline of engineering. It should be inclusive for all.
It is not, ma'am, because policymakers hardly visits actual workplace. If someone enters an industry, he can't find their electrical, mechanical, civil, metallurgy. If you enter an industry and look at what is happening around, you can't find metallurgy, mechanical, electrical, and nobody, and the positions are not assigned as mechanical expert, electrical expert.
Yes, sir.
It is all mixed together and emerges manufacturing as a superset of everything.
Yes, sir. Thank you, sir.
Thank you.
Thank you so much, sir. We are grateful for the time and wisdom you shared with us with your presentation. Now we'll proceed to the last session.
मैं यहाँ से टेक्निकल सर हम उतने अभी जाएंगे वहाँ के बाद वहाँ चले जाएंगे मैंने म्यूट की
Now, I take this opportunity to introduce one of the eminent personalities of Indian IT industry, Sri Mukesh Kumar. He is highly skilled technical architect with over 13 years of experience in developing web-based interactive applications. Holding a master's degree from Punjab Technological University, he is proficient in wide range of web technologies. He has proven track record in designing the architectural framework and identifying infrastructural needs for the products. He currently serves as a senior director at Cognizant Technology Solutions at Hyderabad, where he plays a crucial role as both technical architect and lead. Now Mukesh sir will continue.
Good afternoon, ladies and gentlemen. Am I audible?
Yes, sir.
Yes, sir.
Okay. So let me share my screen and just confirm that you are able to. Hope you are able to see my screen.
Yes, sir.
Okay, so good afternoon, ladies and gentlemen. I was supposed to join there in person, but unfortunately my flight got cancelled and I couldn't join you. And I know you are running little late, so I will try to not cross over your lunchtime. So as told, right, just a little modification. I am based in Hyderabad and I did my master's from IIT Kanpur and I am in industry for past 27 years. Initially, I was in the manufacturing and then later moved to industrial automation software development field, mainly involved in R&D. So today what I am going to cover, right? Let me just quickly give you brief intro what I am going to talk. So you heard about AI yesterday, even today morning, right? You had sessions on AI. So what I am going to talk, how digital twin, what is digital twin and how digital twin is helping in transforming manufacturing systems. So that will be my focus. So if you see this slide, right, you heard this many times since yesterday, different speakers talking about industry 4.0, 5.0, 3.0, all these things, right? So if you see this, right, what this is, right, the whole evolution. So this is nothing but past 250 years of human history. In particular, we are talking about evolution of industry here. And if you go further back in time, so 500 years ago, 1,000 years ago, there was a revolution, right? Scientific revolution happened. And we understood our planet Earth, we understood the solar system, we understood the reason why eclipse happening, why solar eclipse, why lunar eclipse and all these things with scientific knowledge, right? It was not something somebody is doing. We understood the laws of nature. That I call as a scientific revolution. So further, if you go back in time, right, 10,000 years back, so what happened? The agricultural revolution, right? So we domesticated plants, we domesticated animals, and we basically became settlers from hunter-gatherers, right? So that was a big revolution in human history. Go back further in time, 70,000 years ago, what happened? So there was a cognitive revolution that basically differentiated us humans from rest of the animals. We started talking about or describing something which is not real, which is imaginary. we developed those, right, capability. We developed those lingual capability to express something which is not there, something which we can imagine, something which we can talk, right? That was a revolution, right? Now we are talking about a new revolution, similar to that, right? Cognitive revolution, what happened for humans. Today we are talking about cognitive ability of machines. We are into that. So if you see that bottom of this slide, right, last 50 years mainly, right, we are moving in this direction. So initial 30 years mainly it was, we were talking about automations. Now we are talking about autonomous system with this intelligence coming into picture. So let's understand it little better. What I mean by automation or autonomous system. So this journey, so my focus, right, will be just last 50, 60 years, and in which direction we are moving, right, that is I'm going to talk about. And in this, right, we will try to explore how digital twin helped in this journey, right, that we are going to do in this session. So in 1970s, right, when I'm talking about automation with PLCs, SCADA system, computers, those things, right, our machines became, right, more powerful. So we developed rule-based systems. We were able to program things so that machine can move, sense, act with precision. But these things are pre-programmed, right? So I consider this phase that machine became a very obedient worker. So it is helping you to do real-time monitoring, performance tracking, all this you are doing. But end of the day, right, if you see the bottom of the slide, I am showing the supervision is under human's control, right? Machine is not supervising. Machine is listening to you as an obedient worker. That is the automation phase I call, right? Mainly I see, right, 1970 to 2000, something like that, roughly, right? Don't go by exact years. And then beginning of this century, we move to a different era. So I call this transition phase as intelligent automation, or you can call it semi-autonomous phase also. So what is happening in this? Most of us, right, witnessed this transition phase. So AI systems came into picture in different forms, right? You heard from different speakers. They were talking about, I started using 20 years ago, 30 years ago, right? At different places, in different industries, academia or be it in industry, it was at different stage, people were trying this. But end of the day, what was happening? We, right, these machines started, right, learning, reasoning. They were able to do reasoning, so that you are able to solve your problem with advanced algorithms, right? Everything is not pre-programmed. Everything is not rule-based here. We are able to predict, right, future with, right, in the morning you heard from other speakers, right, in this direction, we are able to do with some statistical capability. We are able to predict, we are able to get insights from machines. We are able to do what if scenarios. So what I see in this transition phase, the machines are becoming junior supervisors. So they are sitting with humans. Still human is, right, controlling, taking the main shots. The decision is mainly in humans' hand, but it is augmented by machines, because some of the decisions, right, you can rely on the machines also in this transition phase. But what is our next phase, right, which already started? And I think that we will see more and more autonomous system by the end of this decade, right? That phase, I call it as autonomous phase, where machines can learn, adapt, right, and basically they can self optimize, they can self heal, they can take autonomous decision. All these are possibles with the advancement of AI and whatever technologies we have in the hand. So I don't see that for some of the decision, you can completely rely on machines. That is also possible, right? You may need human in the loop, or you may, for some things, you can rely on the machines, right? More and more autonomy will come to the machines. So I divided. So this is roughly, here I'm talking about 100 years of period, something 30 years of last century, 30 years of 3 decades of this century, and going forward. That is something here I am talking for this phase. But one thing here, right? So all these are possible, right? The technologies and all helping us. So what is the role of digital twin, which I mentioned in the beginning? The digital twin, I am going to use this, right? How this is helping to move in this journey. So first we should understand what is digital twin. I think that is very important. You have heard this definitions many times, right? The physical replica of virtual replica of the physical assets, process, system, or entire organization. But what does it mean? Let's understand the first term. What is digital twin? This term, right? Who coined this? When it was coined? So this term, right? This digital twin term is not very old, right? It started sometime in 2002 by a researcher of University of Michigan, and later it was popularized by NASA, this digital twin. But the concept is not new. That we need to understand it. The concept maybe with not this name, but it was used. And NASA itself used this concept for their Apollo program. You all know, right? The Apollo program, which was very successful, where human using, right, in this program, the mission was to basically man landing on the moon. That was the whole purpose of that Apollo program. So for their third mission, I think Apollo 13, they used this concept, right? That time certainly it was not digital twin, but they used this concept to create that whatever is the environment at moon, how we can test those cases here, and whatever is in their vehicle, can we simulate those things, model those things, so that when landing happens there, we can predict, right, how it is going to happen. So that mission, right, they couldn't land the astronauts who were on that Apollo 13, but they were able to predict, right? There was one cylinder blast happened, and how basically it was risk to the safety of those astronauts, and how they came back to the land safely. So all these, they use the digital twin concept to basically simulate some of the scenarios, and it was very helpful. So the point is here, the concept is not new. Okay, so what is this concept? So let's try to understand from this picture, right? So if you see the left side, I am showing a machine, right? Which we all are very familiar. This is smart machine. Why I'm calling smart, I will tell you. But car, we know, everybody, understand this. Why I'm calling it a smart machine? Because this car has not just mechanical things to drive. There are some other components which is making it smart, right? And I will talk about those components, and all these are part of the digital twin. And if you see the right side, that is, right, in virtual space, we have a replica of this car. So this car, what it is? So we have created with 3D modeling. We have created a car. It can run also. We can use this card for simulation, we can use this card for some training. So basically we have a car model. So the left side, again come back to the left side, in the physical world, right? With this car, we have put some sensors, right? The sensor, what we want to measure, the data which is important for us, right? Then there are some intelligent actuations happening here. So whatever command is coming, right, from the right side, right, which you can implement with the help of these actuators. And then there is edge computing also here, right? All this we put with our physical systems, so that it becomes smart and smarter. So edge computing, what you do that? So there are some actions, some decisions, right, you can take at this level, and you can filter some data, aggregate some data, and then you can push to the cloud, which is in the middle. What I'm showing is a connection between physical space and virtual space, right? And then there is a augmented reality also here. So what it does that, suppose if you open the bonnet of the car, right, you will see the engine and all that, but you cannot see the inside of the engine. A lot of things you cannot see. Those things are covered. But if I put AR application on top of that, it will help me to understand, visualize the inside what is happening, right? Without opening, you can see things inside, how it look like. If it is connected with the cloud or internet, it may even, and some sensors are there, it can pass you the data, it can talk about the health also of the some of the parameters which you cannot see without opening, but you can get those data. So those are the components makes this, right, smart machine. And the right side, if you see, other than modeling and all, we have AI also, we have 3D models, dashboards for analytics and all. So any change happening in the left side, right, that state change is being passed to the right side. And right side, you can imagine this is just right, everything, right, not exactly same, but very close to that. And you are able to do what if scenario. Suppose if brake fails, what can happen? So those things you can create here, right? Those scenarios, and then you pass that control action to the left side, right? To basically take action on that. So there are so this looks very simple here, but you can do for any complex system. And those right, what if scenario is very difficult, right, to do with human, right, experience. And those things are very easy with these digital twins. So this is just high level, but now we will talk about, I will come back later to in factories, in manufacturing, right, some examples of digital twin. I will talk about that. How to create a digital twin, I will talk about that. So, but in general, right, I use this car to explain you, right, how digital twin works. The technologies are similar, but yes, parameter will change and all, right? So let's move to now understand digital twin, what I was talking earlier, right? The different phases, how it helped us, right? Humans. For example, what I'm talking, the automation era, right? And today we are in intelligent automation era, right? So let's talk how digital twin is helping in this. So the earlier twins, right? There was no learning capability in those twins. We created with, I will talk about that, right? How we created in those days. We had some, right, statistical knowledge at that time also, but we created based on the first principle also. And we were able to do, with the help of PLCs and SCADAs and all, we were able to monitor equipment, right? We were able to design tests, what I was talking about, the Apollo program and all. So all this, right, happened mainly with the past data, or if we understand the basic laws of nature, we were able to do that. We were able to automate things. Now, with our pattern recognition or the advancements, right, with AI, ML, and all, we are able to predict scenarios, right? And we are able to validate some of the actions before deployment, right? You cannot, like, everything, something is running, suppose there some blast happens, right? In that blast, you can take 10 actions, but which will be more effective? Those scenarios, right? You predict a blast and then you take actions and then see what works better. So those kind of things you can do with this intelligent automation, which a lot of things we are able to do today, right? The middle is what we are able to do today, and I am talking about the beginning of this century till end of this decade, right? A lot of things are possible. So we are able to solve our problems faster. So this I consider as, it is not just past data. We are able to, it's like a car's windshield, right? And the dashboards, we are able to see what is going to happen in front of us. If we are moving on the road, we are able to see the potholes, and based on the potholes, we can take decision, go left and right, right? So those intelligence is there today in our digital twins. Now, if right, what when we will move to the next era, or which we are moving, we are in transitioning in that era, that is going to be achieved with lot of things without or minimal human intervention, right? We are talking about that self-optimizing autonomous decision-making systems. So there you need to collect that real-time data in whatever form it comes, right? Whether it is a visual, whether it is some data forms, whatever it comes, and you need to adapt your strategies based on real-time information. Then only, right, you can do with minimal human intervention. So we are moving towards that. So these are generic, right? I am talking about the digital twin, what it is and how it is impacting us for last 50 years, and how we are moving towards a new era of autonomous systems with the help of digital twin. So now we'll talk about more about in terms of factories, how basically we are implementing these technologies. So let me take a simple example here, right? So this is a power plant. So in this, there are multiple units here, right? So you are getting coal from mines, and then you are burning that coal or whatever, right? Your fuel you are burning in the furnace. Then there is a boiler where heating happens, water converted into steam, superheated steam, and then those superheated steam goes to move turbine, and you are able to generate electricity. So you can basically create digital twin of each system separately, then connect them, and then you can have a digital twin of entire your this factory or power plant. It looks very easy, right? When I say that we can do that, but how to create it? Let's talk about that. I will take just one simple unit in this. This is a boiler, right? So boiler, what it happens? So you are heating, and then water is getting converted into superheated steam. So if I understand right the behavior of boiler, right? So 2-3 ways we can model it. Suppose we understand the physics, chemistry behind it, right? If I understand why this happens, why this gets heated, how this gets heated. So if I understand that, I can model it very easily. The second way is with the help of data, right? If you are able to generate a lot of data from this boiler, and using that your statistical model, you can do that, right? So there are multiple ways. So I will just tell you before this going into detail, this boiler, right? I am using first principle to create a digital twin for this boiler. So if you see the right side, in right side, the top right, there is a control room. in the control room, there is a DCS, and DCS basically you are sitting remotely in one place and you are basically controlling this boiler. The left bottom, if you see, that is the actual boiler, right? With all these their control systems and all are in place. So what I'm saying that on the top is a digital twin I am showing in a mathematical format, right? So this is a software. So basically I know how material moves, how material behavior changes, like how water as a liquid behaves, then how water as a steam behaves. I know the physics behind it, the thermodynamics behind it. So I put equation for material balance, I put equation for energy balance, and then thermodynamic equations. All these I put and I solve that equation. So suppose right side, if you come back, so I'm just showing on the right bottom the zoomed picture of that boiler. So somebody, if you see that it is a burning and then all parameters coming from the real plant, right? Or virtual plant, that I will explain later. So, but when I change, the temperature, so what will happen if you change the set point, right? The behavior of the boiler, right? You can increase the flow, you can decrease the flow, all these things you can control sitting here. So what I'm saying that if the right, I connect to the twin, you will not be able to really understand whether the change, right? When I'm doing that, when I am opening a valve and when water level is going up, it is coming from the actual point or virtual plant, you will not able to say. If I am able to basically create a very close digital twin. So that's what the beauty of digital twin. But this is completely based on the first principle. And everywhere you may not be knowing how to create those equations, you may not be knowing those laws, and also we will talk about those challenges. But here, this we know for a long time, right? We understand enough physics, chemistry, thermodynamics, engineering, we know. And for many systems like pump, turbine, heat transfer equipments, pipes, we are able to do with our knowledge, right? And we are able to create. So this is the way I was talking about. We create and how it helps. So basically, to train somebody, right? Some operator, I will not use my actual plant, which is on the left bottom. I will use the left top section, and I will train all kind of scenarios, right? If suppose I keep increasing the fuel flow, what will happen? It is going to blast, right? My boiler may blast, my furnace may blast. So those blast scenario we can create, the operator can learn. And also this is used in real time to monitoring efficiency and all, right? So these are the basically ways digital twin helps the way we create it. So now let's talk about not a running plant. Here I am talking about the entire plant life cycle, how digital twin helps. I just took one use case earlier. Now I am talking about multiple use cases possible. If you see this slide, the left side, you have a green field, right? You are thinking to build a power plant or any plant, right? So you are in that stage where you have to do some technical analysis, some economic analysis, but you don't have actual plant, right, in place. Still you can do with these simulators, right? What I'm talking about in your design phase, in feasibility analysis phase, it is very helpful, and it is widely used for those purpose, right? These digital twins. Now come to construction phase, right? So construction, right? Suppose you have lot of equipments, heavy equipments, pipes, and you have a place there. So you can create your 3D models. You will know in advance whether all these equipments, pipes will fit into this space or not. whether the arm of something will move or not, whether the vehicle can move or not, whether the operators or maintenance engineers can access that valve or not. So entire thing before putting into a real life, you can do, right? You can simulate in using 3D pictures, right? And this is not just used for the new plant, even for the existing plant. If you are changing a pipeline, so if you want to understand whether we will have enough space to put this kind of this diameter of the pipe or not, right? If you are doing debottlenecking analysis, so all these you can do first in the virtual world on digital twin, and then you can come and basically construct that, commission that once it is tested there. And now the third here, if you see the rightmost, I'm talking about the running plant, which I took just a recent example. There it is used for a lot of things, right? Efficiency, quality, all this monitoring you can do. So you have the real-time data, and you know from your models what should be the your desired output, and then you can see that whether efficiency is good to go or not. Also, a lot of asset health you can monitor, the failure you can predict, all these kind of things you can do, and optimization of all these resources, right? You don't have to do over engineering. You can do with the help of digital twin. Hope you are with me till this point. What I explained, right? How it is very helpful in each phase of the plant life cycle, right? Right before, from greenfield to right construction to running a plant for whatever life this plant has, right? The digital twin plays a very important role. So what different studies says, right? From this, right? I just mentioned a couple of them. These are in public domain. So what it says that they are getting 10 to 30% gains in productivity. How they are getting that productivity gains? Suppose you cut your unplanned downtime. If you know, right, something is going to happen, you can do proactive maintenance. Otherwise, unplanned downtime impacts very badly. So if you predict your failure and you plan it properly, so basically downtime you can ignore, right? Avoid that. Similarly, the equipment availability, right? Those things can be predicted, can be proactively maintained, and you can gain in productivity. Similarly, in the quality things, right? Different studies talks about different things. In general, the range, right? Some places 25% to 50%, they are able to improve quality. How they are able to do, right? Here, those statistical methods, right? Because using those methods, you are able to predict something is moving, right? And you collect a lot of data, vibration data, movement data, temperature data. And if you correlate these parameters with some potential defects, right, you can avoid it, right? And also you can basically make sure that your quality is not impacted. And you can do some quick root cause analysis also. And then also it is helping in saving material waste. As I was talking about that 3D 3D diagrams, CAD modeling and all, right? It helps you to basically optimize your material. You are not wasting. And sometimes if we don't have those things, we do over engineering. We put as a engineers generally put that as a design factor. So that if it is a very high, right, it is a wastage of your material. So you can optimize that as well with the help of digital twins. So these are just there are many, right, benefits different industries are achieving in different ways, but some of the things just I highlighted here. Now we are moving to the digital twin technology. So we talked about what is digital twin, what are ways to create, how it is helping in plant life cycle, what benefits people are getting. But let's understand it. What are types of digital twins? What are the techniques? So this is important, right? So the right top, I was talking about earlier for the boiler, first principle models, right? So this group of models I considered as a physicists. So in this case, what happens? You understand the laws of nature, and with the available engineering tools, be it CFD or finite element analysis or any kind of solving differential equations, algebraic equations, you are able to model things, and then you are able to predict. So as I mentioned earlier also, whether it is a fluid flow or heat transport, thermodynamics, chemical reactions. So these, where we understand the laws of nature very well, we are able to do very easily. And these are in practice for a long time. This is not like a recent thing. People are doing for 50, 60 years. This first principle, as we know, understand more and more laws of nature better, we are able to create more. Right, I will show one video also, how these things are helping. But before that, just see the left top, 3D geometric and kinematic modeling. So basically, this is like architect, right? When you start building your house, you go to architect, and architect is able to give you entire the rooms, stairs, and front view, top view. Entire thing you are able to visualize with the CAD drawings. So exactly, whether CAD or different types of 3D visualization technologies, we are able to see the entire plant, before construction, after construction, for maintenance. So basically, these are the techniques, You can visualize your plant. You can basically, using first principle, you can simulate the behaviors. So I will show you a video where basically using these two techniques, how we are able to create some of the digital twins. So let's watch this video. Let me know if sound you are not able to hear. Hopefully you will be able to hear.
Sir, you are not audible. उसमें नहीं चल रहा वीडियो.
Not audible? Hello?
Yes, sir.
The not audible, the sound from this video?
Now everything is fine. Yes, sir.
You are able to hear, right? The
Yes, sir, yes.
sound from the this video?
Sound from the video is not coming.
Okay, let me just try. Okay. Now tell me whether you are able to.
Technology.
Is
a
it
digital
audible
physical
now?
world. The
Yeah.
digital world.
It is audible, right?
Yeah.
Yes, sir.
Okay, so I'm going back and let me run again.
Increasingly translated to problems in the digital world, solved in the digital world, and then implemented in the physical world. For domains like process manufacturing, automotive, aerospace, and nuclear power generation, this requires deep understanding of the domain and capability to model the physical world accurately in a digital or simulated environment, because likeness of reality is extremely important. Chemical manufacturing plants are very capital intensive and are costly to build and operate. They are also very dangerous to operate given their complexity, extreme operating conditions like high temperature and pressure, and the hazardous materials involved. Using process simulation technology, a digital twin of the process can be created for the complete plant life cycle. right from design of the plant, from ensuring safe operations of the plant, to allow the process to be operated at optimal profitability levels. The first stage in plant life cycle is process design, where a digital twin allows trying out various permutations in designing before the plant design is finalized and the plant is constructed and commissioned. The next stage is safe and efficient plant operations, where a virtual plant model can be created in dynamic simulation setup which will replicate actual plant process response and behavior. The dynamic model twin can be utilized to train operators to safely operate plants. The final step is analyzing and improving process, or in other words, process optimization. Here, a digital twin of the process is created in a real-time optimizer system, which decides the optimal operating condition for the plant and helps in maximizing production and profitability. The present simulation offerings, however, necessitate the creation of separate digital twins of for the same plant. SimCentral is a revolutionary utilized to train operators and ensure safe plant operations, and the same can be extended to optimize execution of the process plant.
In interest of time, I just basically made it little fast here because I know I am in between your lunch time, right, and you. So basically just I will try to go faster here. But yeah, this is very important, right, to understand that. So this right, digital twin, when we know the first principles, right, and then with the help of 3D modeling, we are able to create, right, and work on that. Now, the come right side, the data-driven modeling, you saw that many examples yesterday and today morning, right? So this is very popular in now, because now you are able to generate a lot of data, store that data. So this this class I considered as a statistician, right? So here you don't need to know why. You just need to understand, hey, what data says. So I have a different set of data, and from that data, I am right able to predict something, whether it is a failure or whether it is a things going fine, not fine. So you know, right? You heard in detail about deep learning and the neural networks, all these things, right? So this category, right, using those techniques, you are able to basically create those where you don't understand the laws of nature properly, but with the data you are able to model behavior. And this is also very powerful when we want to do predictive maintenance, right? Where we don't understand how vibration is linked with some behavior, right? We don't understand the science behind it, but with the help of data we are able to predict quality or predict defects. So that is this class of models. And the third one I consider a hybrid approach, right? Hybrid digital twin modeling. So this is like a diplomat class, right? So this understands, right? This model assumes that there are blind spots for physicists here, like the first principle model, and there is a blind spot for the statistician, like data-driven model, right? So basically we create a combination. Combination means for accuracy, we go for first principle models, and for adaptability, where we don't have the science, we go for this data-driven models. And we create combination, right? Take a turbine. So maybe for wear and tear, you use this data-driven model, but for some of the, right, their functionality, where you know the science, you can create that, and the combination can be a digital twin of turbine. So this is also very powerful technique. Nowadays it is used. So these are just you understood that 4 categories of different types of digital twins. Now the last 2 category, right? The left side, agent-based modeling. You heard a lot about agentic thing and all, agentic modeling and all. So I will talk about that, how this is helping in digital twin. So agent-based modeling is basically a kind of crowd choreographer, where basically there are different actors, right? The actor could be human, actor could be boiler, actor could be a software, actor could be anything, right? So all this, right, you model independently as an agent, right? But how they will work in a complex environment, right? So those behaviors, right, you can do with agent-based modeling. So you have a different agents, right? Agents are basically nothing but different actors. And then how, if I change something, how they will coordinate, cooperate in real life, right? With these interactions, you are able to simulate that, right? So it could be each robot is an agent, or each human is an agent, or each process different. So you can have thousands of agents, and then the agents know how to interact with their upstream, downstream, and then you can simulate the entire behavior. That is agentic based modeling. And the last is right, knowledge graph and semantic modeling. So basically this is like a librarian. So in library, right, how you arrange things, right? You know, this section I will have humanities book, this section I will have science books. Within science, you know, you will put here physics, here chemistry, something like that. Within that also you give a numbering. So basically easily you are able to find. Similar thing is here, right? So you understand, hey, this is a pump, this pump interacts with this pipe, this pump has these properties. So you do entire ontology, right? Semantics, you understand that what properties it has. This pump has these attributes, this is located in this place, this is talking with this upstream, downstream, and then you create a digital twin, a complex system. So in this kind of digital twins helps you to find, suppose if a failure happens, how other system will get impacted because of this. So with this kind of knowledge graph and semantic modeling, you are able to achieve that. So in interest of time, right, each topic can itself take 1 hour. So just I wanted to give a glimpse of that. I have one more video, but I will skip, right, considering the time constraint. But that, right, how the data driven models, right, be created. You have seen some of the things, right, where basically the systems based on the data, you talk in just plain English, right, your natural language, and you are able to ask some information whether the efficiency is right, not, which pump is doing better. So those kind of things. So you can just go on YouTube and you can search, many examples are available in the public domain for these kind of digital twins, which is helping really to move us from, right, left to right, what I mentioned earlier, right, automation to autonomous system. Okay, so I will skip this video. Now coming to what we see future trends, right? So what we see with all these systems, right? We will have, you heard about the dark factory, right? So exactly with minimal human intervention or no human intervention, as we achieve, right, if it is not very complex, or human in the loop, right, depending upon the situation, we will have those kind of factories in future. And how we will achieve that? Because these systems are self-healing. If their problem happens, they know how to heal themselves, right, those systems. So then it is a possible. You can create, right, as I was talking, right, the different techniques. You can create digital twin of entire organization. You can simulate, right, if there is a change, how it can happen. So those are possible, right, some at a small scale available today, but as we move forward in next decades, we will see more and more these kind of systems. And also there is a possibility in future, right, we can use quantum computing to simulate the complex system, where is a lot of calculation required. Today, that is a constraint, right? If it is a very complex system, and if we don't know the result quickly, right, the simulator, if it takes, suppose, 10 weeks to simulate something, it is not of very good use, right? But those things also we can solve in future with quantum computing. and then you can use sustainability optimization. All these kind of things are possible in future with this kind of system, and we will have in future human digital twins also available, and we can simulate those things, right? The human robot can work together, right? And some places there is a possible that it is a completely right a supervisor to worker. Everything is done by a robot itself. But this looks very fancy, right? Very bright, exciting. But it comes with many challenges. Let me talk about few things so that I can take some questions. Also, I can save some time for questions if there is any question. So the data quality, right? If you see that everything we don't know, right? Laws of that particular system. So we are dependent on the data for data-driven modeling. If the data quality itself is not right, if it is a biased, if it has a problem, you are going to create something which is not desired system. And also, right, you have a lot of legacy systems. You are not going to throw everything in the sea and we will come up with the new system. No, it is not going to happen. So slowly we will replace the legacy system. So how this transition will happen? How we will get the good quality data? All these are challenges in front of us. And all this requires a huge investment. Are we willing, right? Suppose we are creating some product today, right? Now we will create the same product, but if we create all these systems, we need a lot of investment in the beginning, right? Later it will help you to maintain, manage and all, but beginning investment is very high. Who will put that money, right? Those things are a challenge. And the major one is the cyber security. So suppose I was telling you, right, the car, lot of instructions coming from the virtual space, right? So your factory or your planes or your cars, whatever is in the physical world, if that is impacted, if there is a cyber attack, right, on the right side, what I was showing, the virtual space, right? If it is not protected, the life will be very difficult. So that those things also are concerns. How we are going to secure those connected systems. And last but not least is the skill gap, right? The workforce, how we are going to train. One is the new right, people who, like you who are in the college, when you will come into workforce, you need to be equipped with these technologies, but there is a large workforce already in the market, right? They are working with the legacy systems. How they can be trained, right, so that they can move forward, right? We are talking about the job replacement, job losses and all, but here we need to talk about it, how they can be retrained to work in the new environment. I'm less worried about the job loss. I am more thinking about that positive things, that if these people are retrained, right, they can be used in the new environment. So overall, right, if I have to summarize in one line, so these digital twins are moving from passive digital mirrors to an active orchestrator in our system. So with this, I will stop here, and I would like to take some questions. There are questions, I think. Might be we are running late, so a little bit delayed, but we can take some questions.
Good morning, sir. I'm Ankit Kumar, and a very warm welcome to NIMT Ranchi. Sir, like you explained about a digital twin, so I belong to a field of Internet of Things. So my question is like the recent advancements in the industries, IoT has become an evident part, and I just want to know like how digital twin and IoT are being monologous and how they're working together, like how IoT is helping digital twins, and what is the what are the future aspects?
Okay, good question. So if you remember, right, the slide what I was showing, I'm not going back to slide because I cannot see you, so I have a limitation. So, but if you remember that my car slide, right, so I was showing on the left side, right, there are a lot of IoT devices you have to put that. Otherwise, digital twin will become static, right? You have a model, but it has not the latest data. So if I have to simulate something, so I need to get data in real time right, from those IoT devices, and then I am able to simulate. So basically, you can consider the IoT devices are a component in the whole digital twin story. It is not like something different. The left side, what I was showing you, those are the IoT devices. How it will communicate, what protocol you will use. It is not like very easy, right? Anything can talk to anything. It will follow certain protocols. So do we have those protocols? Just 15, 20 years ago, it was a big challenge. How one machine will talk to other machine, and every company had their proprietary item, right? So you need to understand that. But slowly we are moving into that, right? Where we have a common protocol, and these devices should be able to talk. If I have, suppose, one system from one company, another system from another company, they should be able to talk easily using these protocols, right? So that is, I feel that IoT devices are just one component in this whole story. Did I answer?
Thank you, sir. Sir, my next question is like I told I belong to a field of IoT, so I just want to know like what projects Cognizant are currently doing in this in automation thing, and how I can see myself in future working in Cognizant with some projects that are being taken, and what are future things that will be undertaken by Cognizant.
Okay, so basically, we were working on this automation. So I will take some examples that you will understand that. So the car manufacturers, right? So today the you're not able to hear me? Is there any
Your
problem?
voice is cracking, sir. Now it's okay.
Okay, so what I was telling, right? Again, go back to the car example, right? Because any companies, right? Earlier, the car manufacturer, they don't need to talk to a software company, right? But today, those car manufacturers, right? Lot of intelligence they put on the car. So there will be a project in most of the software company, right? How to make that car intelligent, right? It is not just doing something remote operation, entire car maintenance, entire the car safety, right? So the data will come from that car, it will go to cloud, it will be stored somewhere, right? Somebody is monitoring that and helping back. So these kind of projects are going on. So I took one car example, right, for car manufacturer. Similar projects are going for the industry, right? How basically those things so the car example was easy to explain that. So everywhere, right, these kind of projects are going on. So you need computer engineer to create those systems. You need IoT engineers, you need electronics engineers, you need sensors, you need all these things. Then only the whole digital twin autonomous system comes into picture. And most of the companies are having these kind of projects today.
Okay, thank you, sir. Thank you so much.
Hello, sir. I'm audible.
Yes, I can hear you.
So good afternoon, sir. I am Aman from final year. So, sir, basically, I can see that everybody now is talking about digital twin. So, is it a very new thing in the era of generative AI, or industry is using it for a very long time?
Yes, I answered this question, but I will again bring your attention. The digital twin term is maybe you can say that 25 years old, this term, but not the concept. Concept is in place for more than 50 years, right? So, but what change is happening, the digital twin, what was in the past with the technologies available at that time, right? It was not that smart as it is today. So with the help of AI, right, with the help of the latest advancement, it is becoming smarter. So that is so digital twin concept is not new. To answer your question, the term is 25 years old, but the concept is very 50 years old, and it is in basically the twin is changing its behavior. It is becoming smarter. See, as I was explaining, right, the 6 types of digital twins. So one twin where I was saying that I know the first principle. So I have a limitation. I cannot create all types of digital twin. With data, I can create a better. But now with hybrid, I can create a better twin. With now you as agent-based modeling, right, AVM, I can create a better twin. So the twins are getting better and better day by day. So that is a difference. But it is not new concept for sure.
Good afternoon, sir. My name is Ankit Rai. My question is that how do you validate the results of digital twin even applied in real world?
Okay. How do you validate the digital twin, right? So let me take a simple example, right? So that I will take some example from your 11th, 12th class so that I can explain it easier, right? So you heard about, right? There is a pipe and there is something is flowing in the pipe, right? Take example of water is flowing from left to right. So what will happen, right? As the water will go right further, slowly there will be a pressure drop in the pipe. What happens, right? The water starts from pumping station. When it reaches to your home, you see less pressure, right? And when you go from ground floor to your top floor, you see less pressure in your taps, right? So the whole behavior of this pressure drop, right? I'm just using your 11th, 12th knowledge. You know, right? You know those equations, Bernoulli's equation, you know how pressure drops happen. So I will create a digital twin and I can say that if I am pumping water, at what point it will not have enough pressure, right? So I can validate that on this virtual thing. And then I will say, I have to put one more pumping station in between. So I took this example like that, right? Whether it is a data-driven or any kind of digital twin, it helps you to validate in that system. And I was using that Apollo 13 example. They are able to do, right, lot of things at on the ground to simulate that how it will behave in that less gravity, zero air situations. So you create here and then you do that testing and then you go and deploy that. Similar examples I took, right? The water flow examples. So you are able to do that offline because you understand that behavior. But if it is not closure behavior, just I am helping you to understand. Suppose my model itself is wrong, then I cannot do that. I will achieve a wrong conclusion because my model is wrong, right? And I am doing validating something on wrong model.
Sir, another doubt that digital twins have in data-driven models are basically using ML models. So why not let's we use traditional ML techniques or just neural networks instead of making a digital twin since it's a very expensive thing. So can we not just rely on ML models for prediction and how systems will behave instead of making a digital twin?
Okay. So first, answer this question: why we need a digital?
To simulate exactly what will exactly happen in the future, how our machines will behave. But ML models can also predict based on certain parameters if we give the values.
We'll come to ML model later. So just you gave it, there is a need we are creating digital twin. The parameter is important that we want to understand it better, right?
Yes.
We want to know in the advance, so we are creating. Should we create digital twin of everything? Answer is no. If we create digital twin of everything, it is a wastage of money. So similarly, right, we choose for what we have to create, and then we choose what method we have to use, depending upon the situation. Suppose if I know the, as I was saying, right, laws of nature, if I understand that behavior, right, we have equations available, I can solve that equation. Even I will not go for a data-driven model. But when there is a limitation, we will go. So whether ML, non-ML, in ML, what technique depends upon the situation. It cannot be answered in generic way. Depending upon the problem, right? On the problem, you decide which method is right.
Thank you, sir.
Any other question?
Good. Hello.
Hope I am not late, right? Not crossing your lunch time.
No, sir.
Okay, okay.
Good
Go
afternoon,
ahead.
sir. I am Suman Saurav, and thank you for the wonderful session. I have two questions regarding the data and the cyber security regarding which you have talked in predictive maintenance. So my question is that you are talking about predictive maintenance. So how is Cognizant using the predictive maintenance systems in their own smart factories? And second question, how you are managing the data piracy and data-driven techniques used in the models? Thank you.
Okay. So this is a very right, you are asking something which people are spending decades, right, to solve this. So just understand it, right? The cyber security is emerging thing, right? A lot of systems or the networks which was not there, or even the protocols, right, which was not in the past, right, available, right? So those days it was very easy. So that's what I was telling that, my company, right, has some protocol. I know how these devices will talk, and it is not connected with internet. So it was very easy to monitor. But now when I open the entire thing, right, this can talk to anything, right? So what will be the protocol which is secure? So this is also emerging. So depending upon the system, right, you have to basically come up with those strategies. But it was not like earlier. The factories used to work in isolated world, right? That used to be, we used to call it OT technology, operational technology, right? And whatever you see here in the software world, it was IT technology, and both were not mixed together. But now OT IT is mixing, and that is a new challenges creating for cyber security, and the new ways are developing, right? When IT OT, that barrier is gone. Now OT devices talking with the IT system is talking with OT devices. The new kind of things are emerging into that. Just high level, understand like that.
Thank you, sir, for the session.
Thank you.
Hello, good afternoon, sir. Myself Anurag. I'm also from final year computer engineering. Sir, my question is like, as most of the new software engineers are into college, and they are now going to the industries, newer industries, they are most dreaded of by this thing, that layoff. As you are a senior management in a big tech company, how you see that situation as a new software developer, and what are your advices to them in their professional career?
So let me repeat your question. If it is correct, then confirm that, then I will answer. So you are saying that people are being laid off, right,
Yes, sir.
from
Yes,
the
sir.
industry.
It's a big tech
So
company.
how the new entrants will survive in this environment? Is that the question?
Yes, yes, sir. As the most senior management are also being laid off by the product-based company also, then how the newer technologies guy which are coming to the industries will survive in this?
Okay. So just I am referring to my last slide, right, the last point. So what I was telling, that job loss, right, is happening for certain skill set. Suppose some legacy system I was using, I need 1,000 people. Now those systems are being replaced with intelligent system, right? So I don't need those 1,000 people with that skill, right? But for the new system, I need people, right, with new skill set. Okay.
Yes, sir. Yes, sir.
So either you train them, right, on the new things, right? They will continue. The new jobs are being created. The old jobs are getting, right, slowly reduced, because those systems are being phased out. So the new joiners, new entrants, I see there won't be a problem if you come with knowledge of latest technology. I'm not expecting that you will be expert of this system, but the way, right, people when joining the new industry, you knew like 15 years ago, right, C Sharp, Java,
Yes,
whatever, XYZ, what was required, you knew that. But today that is not sufficient, right? You should understand, right, the AI system, this system, whatever you're right hearing
sir.
for past 2 days. So do you understand that? If you understand that, there is a need. There is need of those people. So the new people, either they will come learn after joining the job, or they will learn in advance, right, before joining the job. And existing people also needs to reskill themselves.
Yes, sir.
Right? I'm saying that entire, as I was telling, right, in the last slide, if you remember, entire legacy system, we are not going to throw off in a single day, but day by day we are reducing those systems, and we need people to work on the new system with the new set of skills.
Yes, sir. Thank you, sir.
Take it like that.
Okay, sir. Thank you so
Don't
much, sir.
get by thousands people laid off, 10,000 laid off, but nobody is talking about how many new data scientist job came into market. Nobody talks about that.
Yes, sir. Thank you so much, sir.
Any other question?
Thank you so much, sir. We extend
Thank
our
you.
we extend our heartfelt gratitude for your impactful and enriching presentation. Thank you
Thank
all.
you very much.
Thank you all for making our sessions interactive and fruitful. Now we request all the dignitaries and faculty members to please proceed to the NIMT guest house for lunch. Students are requested to remain seated for 2 minutes.
Thank you, Mukesh, for
Thank you.
giving enthusiastic and very awesome lectures as usual. Our students and faculty members were waiting for you, but due to cancellation of flight, this is unfortunate for us that you are not here physically. But thank you once again for marvelous session, and I wish in future you will be here.
Thank you, ma'am. Yeah. So I had full preparation to come there. I was really interested, be in person, but unfortunately, right, yesterday 1,000 flights got cancelled, and
Yeah.
my flight was one of that, right? So no problem. Wish you
Okay,
all the
but,
best for the rest of the session. Yeah.
But
Thank you.
finally, it became successful, and its students had interacted to you, and in future I will call you for interaction to the students in February or March. It is scheduled.
Sure. Thank you.
Thank you.
Now I request all the students to please proceed to the canteen hall for the refreshments.